Hello again. We're now going to see a bit of theory, and reminder for some people, UVW. Yes indeed, we're here now in the section of our training, textures and UV mapping, and we're going to use UVW all the time, so let's just talk about it for a moment. So let's make a plane here, and we'll make it 3 meters by 3 meters. And there we go. Which hasn't got those sizes, so let me just put them in again. 300 centimeters by 300 centimeters, 3 meters by 3 meters. This plane, I'll just leave it there for the moment. I'll hit G for getting rid of the grill. Here's the plane. Subdivision of the plane, let's up that. Let's put 30 or so on each one, on each side. So there we go. Now I make the perspective view full screen by using Alt W, and on this plane I'm going to put an image. This is a JPEG image, and I'm just going to drag and drop it, and now it's on our plane. So this image, as you can see, is put into 4 bits with a U, a W and a V. Right, since we're in theory, I'm going to explain a bit about how this works. We already know the 3 axes traditionally that we use for everything. They're down here in our viewport. So in our perspective view, X is this way, Z is upwards, and Y is off into the distance over there. Okay, so we can consider that on our plane, in the view, that's Y or X, Y and Z towards the top. Okay, so far no problem. But an image is on a flat plane. If now I add a modifier, I'll use parametric deformer noise, which I will use to deform the Z. Now I'm twisting the image. The image is no longer linearly projected, it's following the deformations of the geometry. So before it was linear along here, now it's going along with the plane that we've made. And the same is for this axis as well. Going from this principle, the guys, those famous chaps who gave names to things, decided that X, Y and Z could no longer be used. X, Y and Z are letters at the end of the alphabet, obviously, and symbolizes the various axes, but linearly. They don't take any deformation into account. So now we have U, V and W, which are basically the 3 letters just before X, Y and Z in the alphabet. And U, V and W are exactly the same letters, exactly the same axes. There you go. So there's U there, deformed x-axis, a deformed y-axis, and the z-axis up there. Now, because these are being deformed, they can't be x, y, z anymore, so they're now u, v, and w. So that's why you'll find u, v, and w talked about in the jargon and the vocabulary of all 3D packages, and above all in textures, because textures work with deformations and projections of the images aren't linear. So there you go, there's a little comprehensive theory why we have U, V and W. Before we jump straight into texture creation and UV development or whatever, let's talk about production workflow. When I talk about production workflow, it's everything you're going to do. Often when I do a course, I ask for a preparation up front, a storyboard or a script or whatever that it details your production. So here we've got a scene with a bookcase with books. So let's go and render setup, and I'm going to do a render at video format. So this format is just going to be a standard one. I'm not going to do HD. So it's just going to be 720 by 576. So that's PAL. If I do a render, that's the image I receive. Very good. So Obviously, we know this image is going to be in 16 million colors with an alpha channel, perhaps if I'm going to do post-production. For more information on post-production, which is basically treating the images once they've been rendered or putting on extra effects, let's start with looking at this picture well. So here we can see that my picture is going to be 720 pixels wide by 576 pixels tall. Okay. Right, we're not talking about centimeters here, but in terms of pixels, because we're in RGB, so it's red, green, and blue, and alpha, and this size of image is destined for a PAL TV. This image is in 32-bit or 24-bit. 24-bit if I only use red, green, and blue, and don't use alpha. If I do use alpha, then I've got a 32-bit image. But don't worry, I'll come back to this in a bit. In any case, I will need to have textures on the spines of all the books. So all these books here, there we go, all these ones. Don't forget that we're using a final format that is 720 pixels by 576. Why do I say that? Well, to remind you, I'm leaving my size at 720 by 576. And now let me see the save frames in my perspective view. I'm going to make it full screen, Alt W. Okay, I'm going to need lots of textures here, putting on each book spine. These are going to be books in different collections, and obviously I'm going to need textures on the bookcases, on the different shelves. In my film, I know that I'm not going to zoom into the books. That's very important to know. I'm just going to stay about here, and I'm just going to move my camera around like this. Very simple. Okay, really good. If I'm going to stay at that size, then a texture that's going to be here, that's just going to be on the spine of the book. Well, what size should I put it in, and what extension should I use? Well, given that all this is 720 wide, and it would be really stupid to work on this image in Photoshop or whatever at 1,000 pixels or even more pixels, 2,000 pixels, with enormous sizes, file sizes. In this case, honestly, I think you could just get away with a texture that's 100 pixels wide and at most 300 pixels tall, and that would be ample because I'm not going to zoom in into my books. However, if I am going to zoom in, even then you've got to be careful, so the texture still needs to correspond to the size of the book on the screen, so that here maybe you could do 200 pixels by maybe 600? 600? Why not? Or maybe 700 if you wanted to, in terms of pixels. On these books, on just these books. We're not going to do it on the others because we're not going to see them. We're zooming into these ones. So you can see that we just can't jump into the creation of textures without knowing what we're going to be doing. We need to know what size we're going to be working at. So we can have a look now at the size and also the type of extension that we're going to use, because as we know in computer graphics there are loads of different extensions, TGA, JPEG, and we don't know ever which one to use. That's what we're going to talk about now. RGB explanations. As promised, we're going to look at the different file formats, the different extensions, but we already know that size is important in terms of the storyboard. Okay, so here we've got a color image, and it's in video it uses red, green and blue, RGB. When we've got an image 24-bit. Oh, a new thing. What's 24-bit? What's that about? So a 24-bit image is an image with 16 million colors, roughly. So to explain this, I usually use a little storyboard myself. I'll write on it just with this whiteboard here, so we can see a bit better what I'm drawing. Okay, so the computer is going to use 256 levels of each different color, so 256 levels of red. And to encode 256 levels, you need 8 bits to encode these 256 levels. Okay, so why 256 levels of red and 8-bit? Well, it's like that, you know. It's a bit like a litre of water is the same as a kilo. And so, okay, it took us a while to get us used to that idea. But here, it's pretty much the same process. 256 levels of red, you need 8 bits. So, here we have the value for the colour and how much it costs the computer to do it. It's exactly the same for green, G for green, and B for blue. So 256 levels again, and 256 levels again. Okay, and we're going to imagine, it's always the same here, so 8-bit and 8-bit. So this is bottles that contain a litre of paint of each colour. Red and blue and green and so on. Okay, so we're carrying these 3 bottles. So we take away the glass and we've now got a kilo, let's say. Since I'm really rubbish, I drop the 3 litres on the ground. All 3 litres. Okay? In other words, I've added all the weights here. So all 3 bottles of 8 bits each fall on the floor. That's 24 bits. However, when the colours fall on the ground, they don't stay separated, they combine. So blue with green and green with red, and so you get green and orange and blue and purple and all sorts. So all these colours mix up, so they multiply. And so like that, we'll get 16 million colours. We're actually nearer 17 million colours. In fact, if I start my calculator, you can see 256 times 256, and you can see you get 65,536 levels. For information there, what we've done is 256 times 256, pretty simple, and I've got 8-bit plus 8-bit, so 16-bit colour is equal to 65,536. It's very important to remember this, above all for training that's coming up that's about rendering and post-production. Let's continue. Let's add another 8 bits. So we'll have, what I'll do is I'll multiply this value by another 256. Okay, so let's check that. Times 256. Oh, whoops. Okay, let's start again. It's not going to take long. 256 times 256 times 256. And I can see here I've got 16,770,216, much nearer to 17 million. So that's what we get for a 24-bit number. That's very simple. R, G, and B. 256 levels. 256 levels. 256 levels. These colours are going to mix together, so we multiply these numbers together and we come to 16 million colours, or nearer 17 million as we saw. And the weight for the computer is 8-bit plus 8-bit plus 8-bit, so 16 million colours is equal to 24-bit. So there you go, that's what it means in terms of computer terms. Okay, so the computer terms are one thing, and the extension? Well, we've seen different types of file that do 24-bit, that do some do 32-bit, because they contain the alpha channel. And the alpha channel is the transparency that allows you to put one element on another with a mask. Exactly the same as the weather system, where you've got someone standing in front of a map and they're on a blue screen or a green screen and you do an overlay. It's exactly the same process here. In other words, do we have a need for textures doing this kind of thing? That's what we're going to have a look at now. Don't ever forget from your mind that your final image for this example is going to be just a TV picture, not HD, just an old type of TV, just, you know, a CRT, 720 pixels wide by 576 pixels. What sort of format do we use? We always need to use RGB in 24-bit, 16 million colors, but what sort of format? No, Elephant haven't made a mistake. You're still in the 3D Studio Max training. However, what we can see here is Corel Painter, because that's the tool I use for making textures. Okay, and since it's the goal of the training here at the moment is creating textures, the advantage of Corel is that it always works in RGB. And we can see a 0 because there's no R and no G and no B, which gives us black. Okay, when I change this color here, I can see the RGB values change. And if I take red, going around the chromatic circle like that, and I can see red is at the maximum, 255. Hang on a second, you said there were 256 levels, didn't you? And yes, 0 is a level, so 0 to 255, that's 256 levels. See? Okay, to have a perfect red, all you need to do is edit it, obviously. You can just change the RGB in values, so green 0 and blue 0, and now I've got a red at 100%. Okay, that's not the goal here, it's just to explain a bit more. So, in pretty much every graphics package, we go around a chromatic circle like this, and we go around the intensity like this. And this often is why we get HLS or HSV. We go around the hue, and then we change the saturation and the value. Okay? Okay, let's do a new image. And my new image is going to be the same as my final format, so 720 by 576. Okay, I'm expressing myself in pixels here, but then I don't need to look at the DPI because DPI is always going to be 72. Okay. Here's my image. Let me just reduce it just so we can see our display. Okay, this is our old style TV image, CRT, good old days. This image, let me do some things in here. So just drop down the opacity and let me just paint some lovely colours. So always very good taste, as you can tell. I have impeccable taste. There we go. I'm doing it on purpose, doing these blurred brushes, and you'll understand why in a minute. Alright, now let's use a really sharp colour. So 100% opacity, smaller size, zoop and zoop. And we can do this in any package at all, doesn't matter. This picture, I'm going to save it as into this folder called UVW that I made. I'm going to choose TGA as my first one. This comes from the video cars Targa, which were revolutionary for video, and they made their own RGB format because it was specifically for video, so TGA. So I'll give it a name, I'll call it just A. capital A. There we go. I'm saving that. TGA is a 32-bit format. That's to see RGB and an alpha channel, which here is it's not there, but it's actually in the file. So let me save it. I'm not changing anything here. I've got my TGA file here, and we're in 720 by 576. So now what I'll do is go down to Save As, but this time I'm going to choose JPEG as my extension. But you can choose how you want to compress it. A JPEG. Here you can see the type of compression. JPEG is a format what's called lossy. If you drop the quality down, you will lose quality and you will lose some details in your image. So here, I'm just going to leave it on excellent, it's 100%. Okay. Now, so not as compressed as the other formats, so I'm going to leave it as JPEG, but I'm going to call it to B. And now I'm going to put it at high, 80%. Yeah, okay. And now do the same, but now C. Save, and I'll choose 50% good. There you go. Now I'll continue just to show you the difference between a file that's 256 by 256 by 256, that's 16 million colors, or a bit more, compressed, with a lossy quality expressed in a percentage like a JPEG, and the GIF format. I'm just going to call it A here. GIF is not a compressed format normally, but it's limited in the number of colors it can display. So I'm going to say 256 is the maximum number of colors, and we can dither the colors. So 256 colors maximum. GIF this is a kind of 8-bit file. There are 256 colors that are mixed up. They're not separated into RG and B values. They are just in 256 palette spots. Once these 4 files have been made, let's have a look at them. Let's have a look at the folder, and let's have a look at, first of all, our file sizes. Okay, so the TGA one. It's very interesting to compare the file sizes. The TGA file, which is very good quality and has an alpha channel and has a non-destructive compression. Every point is saved and encoded. So this TGA file, should it be used for a texture? Good question. Let's answer. It's about 1.2 meg. A JPEG at 100%, so not very much compression, is going to be 155K. A megabyte is 1000K, roughly. So that's roughly 10 times smaller. The JPEG that's compressed at 80% is only 26K. That's a huge difference for a 20% difference in quality. 50%, 15K. It reduces a little bit. However, we'll see later on the quality, what's it like. It's not as good at all. It's not even worth that difference in size, because it's compressed 50%. The GIF, it's got 256 colors, and it's still heavier than the 16 million color, pretty much uncompressed JPEG. So it's not the number of colors that makes the file, it's how it's compressed, how it's encoded. In terms of textures, you can forget GIF. Okay, so now we'll have a look at the different types of quality between the different JPEGs, very simply. So let's have a look at JPEG A. Right. So there it is, that's the best JPEG. It's the A JPEG, the one at 100%. It looks very good. There's very little problem with the picture. Now we'll have a look at B, and we can see there are some problems here in the high contrast zones. That's why I made this high contrast. But all this blurry area, you can't see a problem at all. And let's compare the two. Let's zoom in a bit. And you can see that the pixels here are perfect. Anti-aliasing, that's normal. Now if we go to picture from A to B and zoom in again, and there we can see there's some kind of crunchy errors next to our high contrast areas. On the other hand, in the blurry areas, it's fine. It's okay, it works. Let me have a look at the 50% one though. Now, it's terrible everywhere. We can see the blockiness caused by the compression, and look, you can see them there. In other words, if I stay 1:1 without zooming into the texture, the JPEG at 100% is fine. 80% is great as long as there are any high contrast zones. 50%, forget it. Don't ever go down below 80% for a JPEG image. If I now have to go and see the GIF, we can see, and look, if we zoom in, it's just, do we even need to talk about it? It's really not anything you want to look at. Don't use it. Forget it. Forget it as a texture. Forget it. What is to be noted is that I have a JPEG file here at 100%, which is 10 times lower in file size than the TGA. I could even go further. I could even go to 26K with my 80% JPEG. That's amazing. Now, if I go in 3D Studio Max, if I'm going to put an image on here, which is going to be a few K, and each one is going to be a few K, what would be the point of putting TGAs on there? Do you really want your renders to take longer? Do you want them to be heavier in scene weight? That's why it's important to understand the different modes of compression and the intelligence, if you like, of thinking about what your texture should be. Your size, depending on the size of your final render, and whether the camera's going to zoom in or not. And secondly, what kind of compression. A JPEG at 80% would probably suffice for certain places on this. A JPEG here at 100% would probably be better. A JPEG is 10 times smaller than other graphical file formats on the disk. And don't forget that in your environment of 3D Studio Max, you're going to have what? You're going to have lots of things. You're going to have the lighting here. You're going to have all the shadows and post-production, which is going to add more color information to your images. Frankly, JPEG at 80% or 100%, that's the one to use. Right, so let's start putting those images onto objects. Okay, so the technique that I showed before, it's worked with primitives, boxes there. Dragging and dropping images is very fast. Take this image, and I just drag it onto the surface of my object. That works fine with using primitive objects because they automatically generate mapping coordinates. Mapping coordinates is how your texture spreads out over the object. We make a sphere, we'll make a cylinder, and that will suffice to show us all our mapping types. Right. If I want to put this image onto the sphere, well, the simplest is actually just to open up the material editor, going with the pivot to go and find the box, and now we've got our texture there, and we can drag and drop it on my other objects. So let's just give it a name. I'll give it the name No, which is French for name. Okay, I'm not worried about material editor at the moment, but how the textures are placed. on the cylinder, we can already see that there's a slight problem on the top. On the sphere, well, the W's there, and we can look. There's a bit of a deformation there. So let's have a look at the box for the first. Okay, let's right mouse button, isolate selection. Just see that. So my box here, no problem at all. The textures have been placed in a planar projection mode. In effect, what happens is, if you've got a plane, so whether it's got thickness or not, if it's got thickness and it's a box, a cube is the perfect tool for showing UVs. Image is projected. So there's your 2D image from your paint program or from a scanner. This image is projected straight onto the geometry. It's a planar projection, so there's no problems there. Let's just go back to our sphere, and it's exactly the same thing with the sphere. As I said, the planar image is projected onto the sphere. There's the W in the middle, and it's there in the middle of our sphere. Very good. It's very good, yes, but there is a problem. Try and ball up a sphere in a piece of paper, and you'll see it's not exactly easy. What can we see in this case? We can see kind of a knot where all the texture meets. Of course, you can wrap your 2D texture map around your sphere, but when you wrap, you'll find this bit on each side here is going to be around the back of your sphere, and that's how it's joined together. And here at the pole, there's going to be a little problem, and this is the knot of solder, if you like. It's exactly the same thing as wrapping a sweet. So there you go. Here's my sweet that has been wrapped up. And the paper's wrapped around the back, and then you can see that there are deformations at the two poles where the textures all meet up together. So let's go and have a look here. We can see the deformation here on the black line, deformation of the arrow there. There's a black spot at the bottom and the top, and you can see that my image is completely torn around, twisted around. This is going to be a problem on round geometry. Okay, so now let's have a look at the cylinder. Isolate selection. So for him, it's exactly the same process. In other words, I've got my 2D image like this, which is going to be projected directly there. The W is right in the middle, which is fine. The black band, which my image has got a black band around the outside edge, is right on the top, and that black is projected across the top of the cylinder, and the bottom for that matter. So that's why on the two extremities of my cylinder I've actually got this black. If the borders of this image weren't black, then you'd see the colours that they were across the top of the cylinder. So what you need to do to avoid this is to have texture coordinates. What are texture coordinates? It's how the texture is applied to your object. By default, in your modifiers, UV coordinates, so how a 2D plane, an image, is going to be projected into a 3D object. So you can see lots of different processes here. By default, the most simple is UVW map. And that's what we're going to look at in our next video. UVW map on the example scene we've got here. The modifier UVW map. Go in modifiers, go to UV coordinates, and I come down here, UVW map. The cylinder, same as any object, as soon as you get that modifier, just puts planar projection on the object. It chooses planar based on the order of creation. So remember, first of all, you do the bottom circle, which is the X and the Y, and then you lift it up, which is on the local Z of the object. So the first form is a circle, so the first coordinates are planar based on that circle. Okay, so that's why it's here. So this theory is important for different object types, which will come later on. So texture coordinates, planar texture coordinates, we can see them here. We'll just isolate this object. Okay. So we can see there's a gizmo in the UVW map. So gizmo allows you to place the coordinates where you'd like them. You can see that the texture is pulling itself down. Secondly, the texture by default will just repeat to the infinity, even if your gizmo, which is there to position for the texture coordinates, is outside of your object. On the gizmo you can see a green line and in theory a little tab, but you can't see it here because it's a bit too easy to see your axes. For here it's not too much of a problem. However, what's important is what is this green line for? It's basically the edge of the image. Okay, let's go and put the texture into cylindrical mode. And now we can see there's the little didge that goes about out of the top of the cylinder. That's the top of the image, basically. If I put myself back in planar mode, the top of the image is basically here, and you can see the axis of transformation gets in the way. So there's the green edge of the image there. Once you're in the cylindrical mode, then it would be really good to actually try and put it correctly over the top of your cylinder, but it's not always easy to do that. So to do this, you've got a tool down here, alignment, fit. Fit just resizes your UV coordinates based on your geometry. Okay, and now we can see exactly the same principle as for when there were no texture coordinates, because automatically cylinders will generate mapping coordinates by default. The advantage of doing it manually is that I can actually click cap, which allows me to select the cap for the top of the cylinder. So it will join the two techniques. So when you've got an object of this type, then this allows you to project not only a cylindrical coordinates like this, but a special set of extra coordinates, planar coordinates, for both ends of your object, which closes the cylinder. No point using spherical mapping coordinates on a cylinder. You'll get this kind of soldering knot as usual, so unless you're a misunderstood artist, not much point. Let's just put it back on cylinder and change its size with fit. Okay, on the sphere, I haven't really got a lot of choice. Okay, modify UV coordinates and the UVW map. Planar by default. Doesn't work, obviously. We can see that it's projected straight down on the geometry. Cylindrical, not much better. There's a huge, great black dot on the top, and spherical, that's the best fit. Box, it's a bit special for a sphere, unless it's an effect you want. And then you've got face, where every single face of your sphere has texture coordinates. Obviously, this now depends on the topology of your sphere. But we can see little deformations anyway. We'll see how to correct these kinds of deformations. It's coming up soon. Okay, so let's leave it on spherical for the moment. That's probably the best choice. Let's come back to the box, and I'll isolate, and I'm going to put it UVW map. Planar. This just takes my texture and projects it down through the object on the z-axis. When you do planar, based on the order of creation, you've got the image that's like this, that's projected down through, and it's on that top face, and it would be on the opposite face as well. The fact that the borders are black, the black pixel that's on the edge of the image is stretched down its projection. If go in Gizmo and I move it, we can see that now the pixels are just stretched out, whichever pixels are at the edge. And so, there we go. Okay, fit, there we go, very good. So I put it in box mode, and now I can see that my texture is projected on each side of my box. But remember that you've got the gizmo, you can still move it around. You can turn it, and you can scale it as well. There we go. Our little theory about the basics of UVW mapping with basic geometry. What's going to follow is interesting because it's also going to show the importance and the philosophy of 3D Studio Max's modifier stack. Let me make a plane here. I'll take off the grid G, Alt W to maximize my viewport. Okay, in here I'm just going to load the image, drag it straight onto my object. My image is an image that normally is 300 by 300, and obviously here it should be square. It is not. And why? Because the image is taking the proportion and the deformations of the plane. Why? Because this geometry hasn't got any kind of editing of the texture coordinates. It's just going to follow the geometry. Okay, in the modifier stack, if I put the modifier UV coordinates UVW map, now the texture is going to be managed by the gizmo. So if I go back to the plane and change the size, now we can see that the texture is no longer following. Basically, above the plane in the stack, the priority is based on the modifier, unless you deactivate it, obviously. Now if you modify your plane, now it's going to be the same as it was before, but let's reactivate it. So the gizmo is going to be what keeps the original size of the mesh, and which now changes the size of the image that I project onto the structure. If I do fit directly, then I'll put it based on the size of the geometry. So I can change it like so. Now gizmo fit, and there you go. But if you want to keep the real size of the image, the proportions of the image, the 300 by 300, what do I do there? At that point, you do bitmap fit. You go into the folder where the image is, and you choose the image that you want for the size you want. Now you can see down here, we can see 300 by 300, RGB, 8 bits per channel. RGB, 8, 16, 24, so there we go, it's a 24-bit image, 16 million colors. If we hit OK, now I'll find my image size and its repetition. By default, textures are tiled around the world. So to show this, let's make a box, a sphere, and a teapot. Okay. I'm going to get the texture that's on the plane by hitting M for the material editor. I'm going to use the eyedropper and click on there to get the material. And let me name my material, otherwise it's a problem for later on. JYA. Okay, now I'll drag and drop the material on my objects. And there we go. There we are. On these objects, the materials are put based on their basic geometry. When we've got primitives here, we've always got generate mapping coordinates, by default anyway. If I take the box, now I'll use a UVW map modifier on it. Now this modifier, I'll drag it onto the sphere and onto the T-bot. Now it's going to duplicate it in terms of copying. On the box, I'll put box. On the that looks great. On the sphere, I'll put spherical. And when I do fit, it will fit it to the geometry. But I like to take the attributes of the image on this plane. So then we go to acquire and click on the plane. And I've relative and absolute. So let's do relative, and it will be relative to the position of the sphere. So it's the same size as the original image, but repositioned around your sphere. If I take the box and I do acquire, and I click on the plane and I do absolute, at that point it will find the same as on the plane, but it will keep the position of the origin on the gizmo. So I can see the gizmos there in the center of the plane. So whereas before it was actually attached to the sphere. Okay, so when you've got an object like this and you want to acquire the other texture coordinates, absolute to keep the original coordinates and relative to keep them relative to your object. So there you go. There's the possibilities to go and get texture coordinates from other objects, and above all the principle of tiling, where your texture can infinitely repeat. Let's do an exercise. So here's a pretty unique exercise that should make the usefulness of instant textures understood immediately. So I'm going to duplicate my geometry here. I could do it with any kind of object. So do 6 times here, and do Control A to select them all, and duplicate them again here 3 times. Okay. I'm going to take all of them here, Control A. I'm going to go and look for an image now. Let's drag and drop onto my selection. When you drag and drop onto a selection, this is what you get. Okay, that's not exactly what I wanted. I really wanted it to be spread out across all of my objects. The easiest thing to do is to go into the material editor, go into the texture that's on the image, and send it to your entire selection. Assign materials to selection. There we go. By default, the textures are going to be duplicated on all of the bits of geometry. Check well that all your bits of geometry is selected, so Control A if you've clicked on something else. So let's go in, modify stack UVW coordinates, unwrap UVW map, and you'll see that once I put a modifier on a grouped selection, this modifier, you can see, look, it's italicized, which means it's instant. So go and have a look at some of the other training to see what that means. Okay, now all the planes have got a single texture. Visually, we've got the impression that all this is just one single plane, which allows you now to do rotation of each individual object. And, which is interesting in animation, so here we can do something that's quite interesting. Yeah, sometimes you want to keep, they miss the axis and you want to keep them on there, and you can see the texture coordinates that are following, which are symbolized by these orange rectangles. There we go. They're pretty much all selected now. There we go. Select them all now, Control A. I'll come to the end, and I'll just do a localized rotation of all my elements, and there we go. Result. So take the animation off, just play it, and boom, like this. You've got all the bits that are kind of exploding. So when you want to have something where you want to do an object that's breaking, it's like this, you've started that you could actually have your bits of geometry like this. All these are separate objects. And there we go. I think you understand by now. I don't need to actually draw them all. You select them all with Control A. There we go. And now you add a modifier to all of the selection, and then it will be automatically instanced. There you go. There's not anything simpler than that. There you go, for a little exercise that's going to show you a little bit of the interest of doing this. When you want to do the bit that was before it exploded, so we'll do a plane here now, and this is before the thing breaks up. I need the complete plane. So now if I put the texture on this plane, and to be sure that I've got exactly the same size, etc., I go into UV modifiers, UVW map, and I'll do an acquire, and just take it from him, and be careful on the choice. And this choose again, absolute. Okay, now we understand a bit better how it works. So now the two planes have got exactly the same texture coordinates. This one's not got broken texture coordinates, and this one does. Okay, so we've already seen a couple of things, 2 or 3. So we've seen the basics of UVW mapping, so planar, cylindrical, spherical. We can use fit to make sure that our image fits our geometry, or the other way around, so we can make our geometry fit the size of the image, or we can use acquire to take from another geometry. But there are often, as usual, things where you see, oh, what can you use this for? Well, these some little things, we will actually have a look at them now. Okay, right, I've got a sphere here. I'm going to go and get my image, drag it, and drop it onto my sphere. Take my 2D image on my 3D form. My 2D image will get stretched around my object. There's a W in the middle there. It's going to be projected onto the sphere, and it will be wrapped around it, and it will be closed behind it, and we'll have the knots at the poles. Okay, so the first deformation, if we can call it that, is that the image could be considered in a kind of cylindrical form, like this, so that we've got the wrap around our sphere with the line that's behind, and then the tops of the cylinder are squished and are wrapped around to make our little knot, as though we wanted to exactly wrap a sphere with our flat surface. So we've got other things that we can do. If we go into UVW map, we've got spherical, which we've done already, but we've also got, and we'll make a double of my sphere, and we'll also got shrink wrap. So what's that? Shrink wrap basically tries to wrap all the points around a round shape into a single point. Let's have an explanation here. Shrink wrap, how does it work? So here we've got our 2 poles with our little knots for the little bomb ball, and the image was projected from the front onto the object. Whereas this one, the image is above my object, based on the order of creation, and it's projected downwards. But rather than having the things wrapped around cylindrically, the 4 points at the corners of the image are wrapped around and stretched to only make one pole, one solder knot, if you like, welding knot. So you take all the four corners down to one point, and if we do a little kind of animation, little kind of thing, so we can see this is how our image gets wrapped around our shape. So the image, the source image is here, and you can see all the points are stretched down so that they all end up in one single place, which is why the W is a bit larger than before. And now all the deformations are just down here at one single pole. That allows you to only have one pole rather than two. So the one that's here and the two poles. Now we've just got the one pole. So there's the principle. So XYZ to UVW, that's not really for images, that's more for procedural textures. So things like noise, etc. But we'll have a look at that later on. We've also already spoken on it a little bit. Okay. Next up, let's continue our adventure. Delete those, because that's what we've got to do. So there's a box, and let me take my texture, drag and drop. Okay. Now let me modify it with UVW map. There it is. And now I can see in here, I've got the gizmo management here, so I can enter things on the keyboard as well. And I've got repetition, I've got tiling here. So if I do make the size smaller, there we go. And now I can change my tiling, so I can stretch it out like this. This is how I'm stretching my texture out. 0 is probably not a good idea, so let's just change that a bit. There we go. So UV tiling, we can't actually change it here, so let's do 1 here. Okay, I can align it in X and Y and Z. I can use the manipulator, which I don't really do very much. There's a gizmo, I don't often use it. I'm not going to use it here either. So we'll align them directly with fit as before. I can center it. Let's change it around so we can see. Center, there you go. I can align it to the normals. I can do a region fit, other things. So we'll look at those later. What is interesting is the repetition, this tiling. Let me reduce the size of my image. If I only want my image just to be put here, like a ticket, and I don't want it to repeat, it's not the gizmo of manipulation that is going to change it. That's going to change the size and where the ticket is. You need to go into the material editor. So you're going to edit the image. And now where you loaded the image, and it automatically will be in diffuse, just untick tiling there. I'll repeat. Load the image into the material editor, diffuse, map, and I untick tiling. When there's no tiling, then with the gizmo you can move your image around. So what have I got behind? Well, behind what you've got is the diffuse color. That's it. And the image is only put, and it's not repeated, or repeated if you want it to. You can either have it in U and V, or both. It's a bit like X and Y, and that's it. And play with the gizmo to move it around. There we go. For tiling and for 2 or 3 other things. Another little tip now. Well, it's not really a tip, it's more using the tools you've already got. Okay, so we're going to work in a slightly more traditional manner. Here's my teapot, and I'm going to go into the material editor. There we go. I'm just going to drag and drop a texture, give it a name. Oui. And now in the diffuse area, I'm going to go and get an image, bitmap. So let me go and find the image I want. I'll go in here and UVW. There we go. That's the one I want. Right. I want to see it on my teapot, so there we go. Now we can see if we use the material editor, don't forget these things, okay? So you always got to click here to be able to see it in the scene. Right, you can now see that in the material editor that we are on the diffuse zone or area. The material has got a name, we, but the diffuse area just says map number 1. So got to rename them all, please. So I've just called it zone diffuse, which means diffuse zone. And if I go back to my material, we, and then I can click down there and go to the zone diffuse. So to go through navigation a bit faster, I use this, my navigator. So I've got my material and I've got my diffuse zone there. Okay, that's a lot easier for me anyway, up to you whether you want to use it. Okay, why did I show this? Well, very simply, because now I can get rid of the size tiles. So now it will be put on the texture coordinates, which are a bit odd. So what I'll do here now is I'm going to use UV coordinates. I'll select my object first, obviously. UV map, planar. I'm going to do the planar on the Y. I'm going to change the size of my gizmo with scale. And move it around to where I want. That's fantastic. If I turn off tiling, now we've got just the single image map there, as we saw before. But what would be nice here would be just to have the W. That's what I want. So here, should we go into Photoshop or another image editing tool? No. Instead, in bitmap parameters, we'll go down here to, we'll see cropping and placement. If we hit apply, now what I'll apply is the applications that I see in view image. So I'm in crop at the moment, so apply and crop and click view image, and now I can crop my image down and see in the scene it's going to adapt exactly to what I want. All I want is the W. Obviously, don't forget that you're also risking the pixelization of your image, because all this is based on the first theory that we saw before about the size of the image in relation to the size displayed. Okay, that's for cropping. If you do place instead, view image, and now all this is considered like the gizmo zone, and now you can move your gizmo zone around. You can resize and come back to the original image as you like, or change the sizes as you want. Okay, here the number values, so we can move around like this if we are that kind of person, which allow you to work like that. Okay, there you go. What you can do with a little tip like this. This kind of thing is often quite interesting, very useful for doing 2 or 3 little corrections to an image. So we looked a little bit at placing our images and cropping them. Okay, and we also saw at the start theory about 24-bit, 32-bit and so on. So now let's have a look at the options offered in terms of image by textures. Let me make a teapot, nothing more. And this teapot, I'm just going to do a render. There you go, Shift Q, there we are. Now the render, by default, thinks that there's an alpha channel, which is all this black area behind that's got no information in it, the background. This image, I'll save it, for example, in TJ format. I'll just call it IMG, image, in TJ. In the setup, I'm just going to see bit per pixel 32. So each pixel, each point in the image is in 32-bit. All the values are G, B and alpha. The target is going to be compressed but not destructive, and it just compresses flat areas of colour. And I'll hit save. A little bit of theory doesn't hurt here. RGB is my image. Here, compression is not based on the colors, but the pixels that determine the image. And each pixel, which I'm drawing here, is here one after the other. And the compression of a TGA file is not a degrading compression. I'm a bit tired now of drawing all my pixels. It would be a bit daft to actually do a compression based on each individual pixel, seeing as these ones are all the same. Wouldn't it be better to, let's say, let's start our pic drawing here, and all these pixels, all the way along here, are the same color until I hit a point that's not the same color. This zone here will be coded with a start point and end point and what color, and that's a lot less information to save than each little point that goes around my teapot. That's how non-compressed images work. So I've saved it in RGB alpha now in Targa. Now I'm going to save it in JPEG. JPEG doesn't have an alpha. Okay, I'm just call it IMG as well. Setup, and I've got quality and file size and so on. I'll save that. Okay, I'm closing. Now if I go into rendering and view image file, I can see my JPEG image here, and it tells me RGB 8 bits per channel. If I go into the TGA, it says RGBA, A for alpha, which means that this picture has got an alpha as well. It's a 32-bit image, and that is an image that's 24-bit. Compressions being completely different, we can see that even that, though that's 128K, JPEG always wins with only 8K. Let's reset. This is to show you something that works with an alpha channel. So let's make a box. Put a color on it. In fact, I'll do it in the material editor. It'll be easier. Let's drag and drop, and now make the color really tasteful. And now in the diffuse channel, I will go and fetch a picture. I'm going to take the TGA file. I'll ask to see it, and I can see the TGA image in my viewport. If I do a render, that's what I get. Hey, hang on a second. How is it that in the viewport it's black, whereas in render I actually get the green there, and it's all cut out and everything? Well, because when you use a 32-bit image, it will automatically cut out the elements that aren't in the alpha. It uses the alpha channel to actually cut out what you want to see. What it's doing is actually overlaying your teapot over your box. Let's go into a view image file and look at the TGA file. If I just look at the alpha, then you can see the black is transparent and the white is the mask. The fact that I've put an image with 32-bit on my object, it automatically uses the alpha channel. And because in bitmap parameters I've got alpha source image alpha, if I do none and I do render, then the alpha isn't taken into account. The problem with this technique is that the alpha makes a 32-bit file, and so thus a bit heavier. If I change my bitmap from TGA to JPEG, and I'll take the image JPEG that we made, if I do a render, it looks like this. There's nothing that's changed. And now image alpha is grayed out. We can't choose it. If we just look at the image file, you'll see that it's got no alpha channel. This is just a 24-bit image. We can't see the black and white cutout of the teapot. If you do RGB intensity, then it will use the intensities of the RGB values to try and do it. But the problem here is that the intensities for RGB means the luminosity of the image, and obviously there are some black bits in the geometry here, which means that it doesn't actually work. Of course, you can think about not putting dark values in your teapot, but that's tough. Okay, none, opaque. This is the principal advantage of having an alpha channel. Obviously, this is only the case in images that are 32-bit rather than 24-bit. So we've seen a bunch of things now, but there's one little thing that we keep jumping over or skimming or just ignoring a little bit. If we go into UVW map, go down here, we can see map channel. We've talked about it before. Map channel, what's it for? Let's see now, shall we? Let's try and use a few things that we've already done. Okay, for now, let me take this box and I'm just going to put a material on it. This material, I'll give it a name, I'll call it FX. And in the diffuse channel, I'll put bitmap, which I'll go and look for in my folders. Let me see all the types of images, and I'll use that one. Okay, I've already used this. Let's see it now. Okay, and I'll give it a name. I'll call it wood FX. There we go. Okay, this image, as we can see in the diffuse zone and where the M is there, that shows that the mapping is active. You'll see the map channel number 1. Okay. In the maps area, if I turn that off, I keep the color, but you'll see that the little M has become a little m. It's a small m rather than a capital M. Even though it's there, it's no longer taken into account at render time. If you tick it again, now the M is back to being a capital letter, and it's seen at render time. Now, in self-illumination, I'm going to put another image. So I'm going to put this caustic image. What's black in my image is going to be non-active, and what's white is going to be additive. Don't forget, we're still doing RGB. Black is made of 0, 0, 0 in RGB values, and we all know when you add 0 to something you don't get much more. In other words, in additive mode, black isn't actually going to add anything, it's not going to have any influence. So there we go, there's my render, and now all I can see is just the light area just on the wood. Okay, and that was done, so let's call it FX add, and it's on the box. Let's just make the box a little bit thinner. Very good. And it's map channel number 1 as well. The problem is that I don't like it there. If I want it bigger or smaller or put in a different position, if I move the mapping now with the gizmo, I move the mapping of my wood as well. Look, I'm rotating the wood, and I'm doing all the images that are on in the material editor. That's no good. All the images are in map channel number 1. Okay, let's do a reset there. And let's have a look at this now. The self-illumination, let's put it in map channel 2. If I now do a render, I get an error message. Watch out. The following objects require map coordinates and may not render correctly. So my texture 2 on the box doesn't exist. Okay, so now there's a problem. Max doesn't know what to do. The mapping only works on the images mapped, so map channel number 1 will work there, and that's how it's spread out over the box. So what we need to do now is do another modifier, and we go down to UV coordinates and UVW map, and this time I'm going to put it to map channel 2. I can take the gizmo and I can turn the gizmo, and you can see that the wood doesn't move anymore, and when I do a render I can see the rotation of my caustic image and no error message. This way I can actually lay my UV texture on my box differently with 2 different sorts of image. It would be nice to see it, so here we go back to my texture here, and I'll ask to display it. And now I can see just that map channel number 2. So like that, I can change the scale, I can change the rotation, I can change the placement of it, and so on. Very good. And very useful too. And let me close the material editor down, and let's animate. Let me put my texture here, why not? Auto key, and now I'll move my texture just slightly over to here. There we go. Now I'm animating the texture coordinates from my image, which symbolize the reflection. So if I look at the animation, we can see that the texture is moving. And only this texture number 2, in map channel number 2, the wood texture doesn't move. It's just stuck to the box. There you go. Which allows us to now do a little effect, which is quite groovy. So let's have a look at the render it can give. So we go render, range from 0 to 100, and render output. I want to save a little AVI file that I'll put in my folder. I'll call it test. Let's go down and choose AVI. Yep, and hit save. Now choose my encoder. Okay, hit render. And here's the video. It shows my little animation. Now you can see the texture in map channel number 2 that's moving, and the texture on map channel number 1 that's not moving at all. There's the explanation for map channels. The map channel trick that we've just looked at, it's very useful because it allows you to put 2 different textures in different places. Okay, but that's good. 2 different textures on different places. So we put one in diffuse and we put one in self-illumination. But here I'd really like to actually put 2 textures, 2 different ones, but both in the diffuse channel. But let's have a look. Okay, there's a box. I'll convert it to editable poly. It's very important what I've done there. Converting everything into optimal polys. Everything should be polygons, really. We're not going to work on primitive objects. We're going to develop a bit our learning here. So now we're going to put a material on it. The fact that I've done that means automatically it's assigned, we already saw this, to a material ID number 1. Okay, if I take a face now, I can put another material on it, and that's all. That's pretty good, because that means that you can have more than one material on a single object. So I'll put a bitmap on here, my UV map, and put it on there so I can see it. There you can see UVW is everywhere, but not on the top face. So the top face has got a different material. Let's have, we're going to have a colour there. That's pretty cool. Let's put another bitmap, and this time I'll use my Amarok image, and I want to see it. Okay, it's because we converted it into poly, and now Max doesn't know really what to do, and doesn't know how to lay it out in the viewport. It's on our face and doesn't know what to do. We could have, of course, we put it in face map, and then we can see it, but that's a bit daft, because what if you've got more than one face that's been used for this second texture? You're not going to use that. So here, for this material number 2, as we can see, let's put a modifier UVW map again, which will only work with that one polygon. Now we can see that the mapping here is only going to work on the texture that we've put on the top face of the box. There we go. There we go. Right, so for the other mapping, it's going to keep the map channel number 1, obviously. So if we want to take a modifier in there, UVW, UVMap, and box, and by default it works on map channel 1, and there it doesn't matter about the order, and so we can change the scale and so on. These two materials are now on a single object. To stop redundancy and use of all these thumbnails here, once the materials are done the way you like, take the third one there and you go with the pipette and you do that, and automatically you've got your two materials. There's ID1, ID2 based on the faces that were selected. Okay, like that we can see that we can put two materials on a single object. It's not bad, but it's a bit heavy. Why do I say it's heavy? Because UV map, and so on, we're just filling up our modifier stack. Thankfully, they've improved things, so we can go further with Unwrap UVW, which is the unwrapping of the texture, which is so much better. But now we've seen more about the basics, we'll understand this tool more. Once you see this tool though, you're never going to use anything else. UVW map, but that's allowed me to understand and to learn how to use Unwrap UVW. So to start our look at Unwrap UVW, we'll have a look at how to put two textures onto, or two texture coordinates onto of the same image on one piece of geometry. So let's start with some basic modeling. So let's go in the top view. I'll make some lines. I'll hold down Shift so I turn at 90 degrees, obviously. Okay. Now convert to spline, or take the spline, take the line there, and let's turn outline. If you need to remember how to do this, go to see the modeling, basic modeling. Let's take off the grid so that we can see easier, and we'll do an extrude. There we go. Right, now I'll make that into polys, and I'm going to just add a texture on the whole thing, and a texture on the top and bottom. So I'll apply that there. So to see that easily, I'll just give it a different color. There we go. Okay. Right, we're going to start now to work in a slightly more professional way, pragmatic way. So let me take this empty slot with a pipette and click on there, and now I'd like to delete those two slots there. So what I do here usually is just reset material completely. Now there's nothing, everything's cleaned up. Take the first one and eyedropper, and then I get them both. Now I've got all that interests me. So there's material 1, which I'll call mur face, which is the sides of the wall, and that's mur dessus, which means wall top. Okay, in here I'll just change that default, I'll call it brick. I'll go back up, and there I'll call that peinture, or peinture jaune, yellow paint, because we can see it's yellow. Okay, so I'm not changing much. Okay, in brick I'm going to choose an image for the diffuse channel, bitmap, and I've got my bricks here, and I'll ask Max to show the image. It can't show me the picture because it's an editable poly. It's not a primitive object that's got automatically generated texture coordinates. So if I do a render, it's going to come up with error. Okay, so if I hit continue, then you're not going to get anything. The same result that you get in the viewport. That's not very good for texture terms. So let's rename it to wall, our object. So now what I'll use is map channel number 1. Okay, that's good. Modify UV coordinates, unwrap UVW. That was the whole point of this chapter, wasn't it? Okay, so there we go. What's happened now? Well, what it's done is it's put a planar texture by default based on the history of building the object. So the first shape that we made was this line at the bottom, remember? And that's the base. That was the first form that was made. And it's going to place the texture based on this orientation of this first form, and it's going to apply it on all the surface. That's why you've got all this stretching, because it's in the wrong axis. So now if I go into there, there's no edit gizmo, so because this is a lot more powerful. So what I do now is select the faces. So I'll take these ones here. They're in bright red at the moment. If this bothers you, you can always just turn it off by pressing F2 on the keyboard, but I like it. I'll leave it like that. Right, these faces are selected, so now I'll put a planar texture on them. Still not right. It's still, by default, it's put it on the wrong axis, based on the first line I drew. So I can choose align Y, X, Z. Y is the best one, I think. So, and now it's really simple. So you move it around, change the scale. Let's drop it down a bit. There we go. And squish them up a bit. Okay, what we can see here, which is a bit problematic, is that there's a complete latency between where we're moving the mouse and letting go of it, and then the texture updates. This isn't complicated. All we need to do is go into options. So if I open all this menu up, if I go in parameters, and then edit, and in here I go into options. So here, preferences, I can see constant update in viewports. Okay, close that and close these all back down. I don't need parameters there, and I can reduce this down. Okay. Now, when I do my move, I get an immediate update. It's much better. Okay, what I'm going to do now is turn off planar. I'm still in face mode. I'm going to select the other faces that interest me. So here and here. And there on the other side. So I've done a multi-selection with using control. I use a planar texture, and this time I want a line on X. Alright, like that. We've now got a texture in one sense and in the other. So we've now got real-time adjustment, so I can just change the scale and see what it's doing, and change where it's placed. There we go, so we can match up the grout a little bit better. Let's change the scale a bit more. Okay. And like that, we've now got an agreement between the grouts of the different parts of the wall. So if I leave now, so the green lines are just the cutouts that I've made every time I've done a planar projection. So if I now convert to poly, and all the texture coordinates will be contained within your object. So now it's a lot simpler to actually place the texture coordinates where you want. You can always readjust your texture coordinates, because that bit's not exactly nice. Just by re-editing, when you've converted to poly, texture placement was saved inside your polygonal object. So if I just go back to unwrap UVW, and now I can see there are my green lines. If I choose face, I can select this one. I just want to adjust this one. I'll put myself back on planar, align X, and choose the scale, and I'll work on it a bit more. That's better. To have a better kind of adjustment. And up to you now to work on this to get a better alignment. If you delete the unwrap, you'll find what was saved in your editable poly. So there you go, now you know unwrap UVW, and you've seen it in use. Okay, so how do we now put different types of texture coordinates? Because in the last example we saw planar, but maybe we can use different ones. For this example, this is the chisel we made before, remember? And now let's change it, give it a material. Will allow me to see the texture coordinates easily. Let me see this object. If I ask to see it, we won't see anything because this model was made with loft, so we need to put some UV coordinates on it. Unwrap, and now we can see automatically the image is displayed. If I go into face, if I select these bottom faces, if I do a front view, left view, yeah, that's better, and I select these ones underneath. These ones, if they're selected behind, no, they're not selected behind because we had ignore back facing turned on, because it's on by default. So let's go back to our view and we'll start again. And now we can see that they're all selected in front and behind. And now have a look. The texture by default is a planar projection. So down here I'm going to put a cylindrical texture, fit, and texture is now cylindrical and fits around that handle. Alright, let's now select the ones just above it. I've got a ring, and I'll do another cylindrical texture, fit. And now let's select the blade, the face that's on top. Quit cylindrical and select those ones a bit more. Okay, and now I'll choose planar. Fit again. Watch out, the planar's on the wrong axis because it's based on the history of creation. Let's put it back on the Z, maybe on X. That's best. Okay, I can now see that I've got my 3 texture coordinates that are different and that are placed on my object. So like that, without any trouble, we can put textures on our object. But is there another way of doing it that will allow us to go a bit faster? So let's delete the unwarp and we'll keep everything that I did. So I selected the top faces there, okay, and what I'll do is I'll give them a number. So down here I'll give them set ID 1. That's fine. Okay, so let's go back to left mode and select these ones now instead, and I'll give them set ID 2. 2 on the keyboard, and I'll hit enter to select my decision. Now I'll select these ones down here, and I'll check the set ID to 3 and hit enter. And verify. Now select ID and I'll choose 3, select, I'll find the handle, 2 I find the ring, and 1 and I find the blade. The fact that I've prepared these numbers for identification will allow you to put textures on by these numbers, different textures by these numbers. So now I could go into, not into a standard material, but I'll use a sub-object material. So again here, standard and multi-sub-object. Okay, I'll kill the other one, doesn't really matter. So numbers, I'll only need 3 materials. And so here, let's see the colours first. So put it on the object, 1. I'll modify the colour rapidly here. So just put green. I can see that that's the 1 bit. So 2 is the ring in the middle, and 3 is the handle. If I wanted to have a different texture for each bit, so I go in here, diffuse, bitmap, and I can pick, for example, my caustic image. It's a bit odd, but never mind. Okay, let's see it. I can't see it. Okay, because there are no texture coordinates still. So if I go back up, on the 2 I'll put another image. That's the ring bit, so let's put with the bricks. And still no image display. Let's go back up, and on the 3 I'll put another bitmap on the handle, and I'll use the Amarok image, the wood. The wood is fine. Okay, now I can ask them to display, and they won't. There's nothing there because there are no texture coordinates. So here's a rapid technique to actually recognize polygons faces by ID 1, 2, 3. If I add a modifier unwrap now I can select. I can see the textures are met. I can assign the textures differently. If I take by face, I can choose select material ID 1, and those ones are selected. And now I can go directly down to planar, align to X. I quit planar now. Go back up here, select material ID 2, and that's the ring in the middle. Cylindrical, fit. Quit cylindrical, and now go back up to select material ID 3 and choose cylindrical again. I'll align on Y or Z, and I'll do fit again. Be careful on the alignment. And there you go, there's a rapid technique to put textures onto an object. Once your textures have been placed onto your poly object, you can put another modifier on, you can put a turbo smooth on if you like, with no trouble at all. The textures will follow. Okay, sorry for the bad taste of the textures, but now you can see a rapid technique that allows you to use the material IDs, the selection IDs. The IDs are used a lot for materials, but also for the recognition of different textures very rapidly, which allows you to stop having problems with selection like I had before. That's why I showed you both options. Let's see what else we've got instead of just planar, cylindrical and others with this character. This cartoon character, I'm going to put a texture on him, a material on him, and just assign a bitmap to it. Let's use this UVW bitmap and choose to see it in the viewport. There we go. Now if I go into front view and put myself like this, so right now my cartoon character is right in front of me. Now I'll put unwrap, I need to select my character obviously, unwrap UVW now, there we go. Let me take the faces that interest me. So don't forget that when I select these faces, I haven't got, or rather I've got it activated, but I haven't deactivated it, which means that faces that are pointing away from me aren't selected, so neither are these ones on the side of the nose. So to select them, just hit plus on here, which will allow you to select the faces that are adjacent and communicate directly with the ones you've already selected. Okay, so here I am, I put myself in front mode again, front view, and now I'm in front of my character. Now alignment, I'll do planar for example, and best align. Automatically it will align the texture to my view, and that will make my UV coordinates dependent on my polygon selection. And that, now we've got a beautiful projection on my character in terms of a planar projection. We can afterwards go in and add a modifier of subdivision, so like turbo smooth for instance. Without any problem the textures will follow. There you go. As I drop it down and put it back up again, the textures follow turbo smooth. So that was the very useful best aligned utility, there we go, in unwrap UVW. Let's have a look at some other utilities. First of all, modifiers, I'll put an unwrap UVW. And I'll select the faces that interest me, so the ones in the front of the character, and I'll put a planar map on him. Just to remind you, if I do best align now all the selected faces will be put into a planar UVW map, with the best axis and adjustment. Okay, I'll click on the little plus so that we can take into account the adjacent faces. There we go. Okay. Other tools here are easy to understand. We all know fit, that will rescale the texture to fit the selected faces or the components of the object. If I do center, it will recenter on my object. Since I already fit my thing, that doesn't really make a lot of difference. If I do best align and then do center, then you can actually see that it adjusts it automatically. And obviously reset resets the texture coordinates, and there are none now. To delete your texture coordinates is pretty simple. All you need to do is take unwrap and hit delete. On the other hand, the object has still got its material on it. I'd like to disconnect this material from my object with all the things that it's loaded in the material editor. That's extra. So if we go into utilities and we go more, and if we scroll down, we've got remove mapping. So if you scroll down, UVW is the second from last from the list by default. So we'll hit OK on there, and we'll be here. So if we choose set grey, the object will become grey as soon as you hit remove materials. If you remove UVW, it won't work unless you're in editable mesh rather than editable poly. So be it. Materials works really well, so if I do materials, there we go, it's done. Obviously the connection with the material up here doesn't exist anymore. They existed before because there were the little triangles, remember, that signified that the texture was used in the scene. Let's check. Let's drag and drop the material on there, and now you can see the triangles are on there. Remove material and they're gone. The fact that I ticked set grey means that now the object is grey, that's all. You can put whatever colours you like on there, and you can choose the default colours. There you go, and you can change whatever you like, it's up to you. There's some extra little utilities which can be handy, that's why they're called utilities when we need them. We'll now look a little bit further. UV mapping flat things. Heads we'll come back to, but this type of thing. This is why I say going further, because going further, you go with a road, go further, and I won't say anymore. Let's put a texture on this object. So we can see this is a polygonal object. If I take the faces, I'm choosing faces by angle, 45 degrees, and there we go, I've got all the road faces. On these faces, I'll put another material. This material is pretty simple, just diffuse, and there's just a bitmap, and there's just a white rectangle on a black square. And that's it. If I ask to see it, it's a bit daft because it can't show me. Okay, so to follow up, I need a line that corresponds to the geometry here. So this line will allow me to distribute the image along the road. Okay, so I need to extract a line from this road. So that's what I've done. I took a line here on my polygonal object. So to select a line, just go to segment mode, select a line. That's not difficult. And I'll just do a loop to select the whole thing. To convert this line, create shape from selection. And then I'll make a selection there, and I'll call it ligne, which is French for line, and I'll hit OK. And there you go, I've now got a shape. And there it is, it's completely extracted from my 3D geometry. I'll leave it slightly above so we can actually see it a bit better and select it easier. Modify, UV coordinates, unwrap UVW. So now let me select what kind of face. I'm going to select faces by angle, and exactly the same thing as we've already just seen with the polygon selections and with everything I showed you in previous training. Okay, here I want to distribute the image along a spline. So pick spline. I can either click in the viewport, which is the easiest obviously, but if you can't do it, hit H on the keyboard and then you can select it there. Okay. the distribution of the texture is made upon the line. By default, the line looks like a cylinder. The texture will be deformed in a circular fashion, so we'll change mapping from circular to planar. Okay, so now the mapping is planar, but a little bit narrow. If I look here, by getting closer, I can see that this bit here is too thin. So, and we can see that it's divided into 4 bits of control. So 2 extremes here, so I can change the scale on this bit, and then other bits in between. It's a bit laborious to do it on all of them, so let's just drop it down to 2. There we go. Now if I scale here, there we go. So it's just getting rid of the number of subdivisions to control your line a bit better, and then the other end of the line is going to have the other control point, so there, and I can size it up there. So now it's sized up my whole line. So the line is now more or less well positioned, but I think I'd like to actually add a cross section here. I'll turn off add, and now I can remodify just an area of the line that I need to. So I can change the position, okay, which allows me to change up errors. So I can rotate, which will allow me to control the distribution of the texture. The texture is what? It's just this white line, and you can see the white line there. So we don't want this stretching, so all we want to do is up the tiling. And now I can see my dotted line of the road. If I hit F2 so I don't see the red selection. Okay, if I adjust the position a bit, just simply like this with the middle line and the ones at the end as well, which are the controls for my spline. For this type of shape, it's a lot easier. Always do the end points before you do the one in the middle. And repetition will allow you to concentrate your white lines to make bigger or smaller lines. Once you're satisfied, commit, and now that's considered as a plane. There we unwarp with a line. Let's go on now, still with the line, but using it in the cylindrical manner. Let's carry on with UV texturing using a spline or line. So here we've got a piece of a candy cane and my material. The material, let me assign it and let me put a gradient ramp on there. So I'm just going to look as a gradient, and there you go, it's not very interesting. So let's just modify it a little bit with putting some extra colours on there, always tasteful colours obviously. After all, it's a candy cane, so it's got to be of interest to children. There we go. There must be some colouring in here, I think, probably. Artificial colouring. And there we go. Interpolation, I'm just going to use solid so that the colours are just go in blocks. And now if I use a UV coordinate, so unwrap UVW, this is what I get. Now I'm going to just make a line in the left view, and the line is just going to be straight. So I'll hold down Shift and draw down. It's going to serve as a direction for the UV coordinates. So hold down Shift and then do that, like that. That's enough. I'll put it in the middle of my candy cane with a quick align. Lift it up. There we are. Right, I'm going to pick my shape again, my object, and I'll come back to unwrap UVW. I'm going to take all the faces, Control A, and I'm going to use spline. Pick spline, there we go. And now circular is exactly what we want. I'm going to reset the count to 2. Reset. Now I'll take the top one here, I'll make it a little bit bigger, and the one at the bottom, I'll do the same. Right, now on this top one, let me rotate it a little. As I turn it, we can start seeing that the textures start turning as well, start twisting. So all I need to do is follow the twist of the candy cane, the twister, and so not go too far. Let's just see if we can match the turns of the candy cane. Obviously we can change the scale, we can put one in the middle, just exactly as we did before. This is a little bit easier than the road, but let's do a commit. Alright, now if I go back to my material editor, and obviously I can up the tiling so that we have multiple stripes per stick. Okay, applications are enormous, so you could use it for tree trunks or whatever, so that you can have a twist or even correction. So I've used this before on cup handles to decorate them a bit better, so that the position was better. Other techniques now, perhaps more easy or more speedy to do an object that looks a little bit more complicated, in this case a hand. What I'm going to use now is a basic material, so let's hit on here and a checker. I'm going to see what that gives me in my viewport. Not a lot. Let me change my tiling. Okay, 5 by 5. There you go. Now let me convert this object into polys, and I'm going to use unwrap UVW. Okay, now when I select faces, the ones on top, let me go into the top view and just take the top faces like this with my lasso. There you go, there's my selection mode, and I'll do a quick planar map. My selection's done now, so if I do Control I to select the faces that weren't selected, so everything that's underneath basically, quick planar map. Now I've got a texture that's on top and underneath, and which is very rapidly done, and is the checkerboard. Obviously the sides are a bit difficult, so quick planar map just allows you to go quickly just to do a test. For now the hand could be considered done, but once you've got several textures, so we can see that my planar hasn't been really very well done. Let me do Control Z to go back, and where's my planar map? This one, we'll try and make it a bit better. We'll make it a little bit more planar. There we go. And we'll do a fit. Okay. And we'll Control I to select the other faces. And fit. And then, so we get roughly the same kind of things on both sides. Turn off planar. So we've got roughly the same orientations, and since it's got the same on both sides with fit, that the areas where it touches are much better now, because so what have we got other as a utility? We've got this one down here. We've got tweak, which allows you to readjust textures if they're not quite right in certain places, and this allows you to take the points in your UV texture to move them and move the texture around on them. So that's good. We've got lots of little tools, but how do I do it if I want to see this texture and to use it for that matter? So it is where it becomes very, very interesting. Okay, so I've skipped over Pelt at the moment. We'll have a look at that later. But now, what we'll have a look at is just basic things. So what we're going to look at now is we'll go to Edit. Edit is going to allow you to see the UV map that you've made, how it's been cut out, work with another image. We're going to edit on the following chapter, but I just wanted to show you these two little quick utilities, so Tweak and Quick Planar Map. So let's have a look now at actually editing my textures. So here's the menu. Well, it's pretty simple here. It shows you the image of your unwrapped UV. You can manipulate points, segments, or faces of your UV. If you do select elements, then you select the two elements. What two elements? Well, it's basically the two sides of the hand. So there's my one on top and one underneath, and then when I move them, I can see the texture moves with me moving the objects. So I can see there are some points here that weren't correctly welded. So for the time being, let's select them like that, and just let's move them over to the side a bit. Okay, a bunch of information in this window. Right, so the background image there is checker pattern by default, but you could choose the texture you actually added to your object, and now you showed the texture that you chose in the material editor. If you didn't want, then quit the menu and start again to refresh. We'll have a look at that later. Let's put the pattern back. This is a checker pattern by default. Okay, so we can select the elements rapidly and we can turn them with presets down here, which allow you to do mirroring and turning them on horizontal or vertical, and so like that you can almost not have anything. Handily, Control Z works. The most interesting, which we're going to see rapidly because we actually want to get on with texturing our hands, so let me show you this though. So it would be nice to have these as images now, so I can do the inverse process. So I've unwrapped my 3D and I'd like to have it as an image so I could draw on it. So if I do a render right now, I'll have a big problem. This square that's drawn in the background here, that is the format of the image that will be rendered. Okay, so what you can say here is that the hands are out of the frame. So here we've got all the standard tools. You've got move, rotate, scale, or you've got freeform mode. Or you can select them all and you can do right mouse button and see them. So let's choose freeform gizmo. So what this does is it allows you to change the scale. You can move around, and when the mouse pointer changes and it becomes slightly wider, then you have got the center of your reference. Why? So that when you rotate your thing, that's what you rotate around. So watch out for the mouse pointer changing shape, getting slightly bigger, so that you can move the center of rotation. Let's change the scale. And now put all these elements inside my square. Let's take these and scale them down a little bit, because I don't really care about them. Okay, and now do a render of this image. You've got the tools. Tools, render UVW template. And now in here you determine the size. Back to what size is important. And so 1024, that's going to be a bit big perhaps for unless you zoom in onto the hands of this person. Let's change it down to 500 by 500. Okay. You've got all these other things, and I won't look at them anyway at the moment. I'll just do a render UV template, and there you go. There's my image, and you can save it. Any type of program that will allow you to feed the information, which can then be put into your UV texture map. Deformation here is not great. It's not great that we've deformed the pixels here. So let's change in free transform. Let's just change the scale a bit. There we go. I'll just move those and scale these down again. And move them out of the way. And put the two hands back on our UV frame. Okay, there you go. These ones, I'll just put them in the middle here, out of the way. A little bit smaller again. Okay, for the options, we can see here, we've got none here. We've got solid as well, so when we do a render, now they're solid. The red squares are the little errors which have been made in colour here, overlapping. Normals, shows you a normal map. The orientation of your faces. Shaded, which allows you to show how he looks in 3D Studio Max with the lighting and shadows cast, etc. If you want to see segments, you can turn on and off visible edges. Seam edges, so you can see the green edges there. I just leave it on none, and I render. There you go, this image. Now I'm going to save it. I'm just going to save it as a JPEG image. I'll call it main, which is French for hands. There you go. And save. Bingo. Now I'll close that, and close that window. Now let's head to our image editing package. So here are my hands, and here we are in my paint program. Drawing directly or bringing a scanned image, whatever, put it on here. We could do it with the face, but here we're going to try and go quite fast like in production. So this image, all I'm going to do is select the whole thing. I'll do a Control C and a Control V. So now this image that I completely selected, let's do it again. Control C, Control V. What I'm going to do is find it in my layers section. Oh, and I actually took two, so there you go. Only one will do. Okay, canvas is the background image, so let me choose the color that I want, the color of the skin, roughly. Okay, I'll select everything again, and I'll just fill it with that color. Obviously we don't see that color very well because the leather that's over the top covers it up. So now let's change its opacity so that I can see it underneath. So anybody can do this. So on my canvas layer, I'm just going to choose a brush, and I'm just going to pick a color, and choose the thickness and the opacity of my brush. And now I'm going to paint just in the places that interest me. I'm just being careful for the connections that there may be. Okay, so this is just an example, obviously. Let's just turn down the opacity a bit more so that we can see our background more. And I don't want to paint on that layer. I want to paint on the canvas, on the background layer. There we go. So just doing some highlight there, just get a little ready fingertips. Like so. Okay, that's pretty much it for that image, so let's just do a little bit of softening on there. Okay, and I'll turn off the layer. So that's my painting that I've done. Now what we're going to do is do something with a bit of more contrast at some point or other. There we go. So it stands out more. There we are. Now I'll turn off that layer. I'll resave that. I'll keep it the same name. Why not? Do I want to replace it? Yes. Okay. And I'll just choose high for the JPEG compression. If I now go back to 3D Studio Max, the materials editor, rather than the checkerboard, let me choose bitmap and choose my hands picture. Now I ask to see it, and automatically what happens, I see it in my viewport. My mapping, which has been applied to my objects. So very simply. Okay, let's convert this to editable poly, and let's use deformer, subdivide it, turbo smooth. There we go. And there we are. The triangles that were problems, well, there they are. And there were some others as well. We could correct them, and we could paint over them. Let's see now. There's my image that's been put on there. Let me go back into my paint package and look at that layer. And now there are the ones that are causing the problems. So let's just, we could find out what they are just by painting them in a very black colour. And let's just save the image again. Let's go back into Max. And there they are. There with the black triangles. And the one on the wrist as well. Okay, like that. That allows me to work pretty quickly to be able to do UV mapping coordinates. Okay, obviously you could work a bit better here and you could work a bit cleaner as well. That's what we're going to do next with the head, but obviously you can see the way it works. Making a head. Okay, I'll show you a few little things to go a bit faster. As promised, let's now do a head. Okay, so a head, yes, but a basic head. This is a head for a secondary character in our scene. For our head texture, let's be a little bit sensible. What we're interested in are the eyebrows, the mouth, maybe the beard. The ears, I'm not really that interested in them. It's very rare that you actually find people with tattooed ears, for instance. So from there, let's use a rapid technique. So I'll select my object, which is a polygon model. Modifiers, I'll use UVW map, the old one. Cylindrical, and I'll fit. And I check now around at the back particularly. If I look at the gizmo, I can see that the joint, the connection of the texture is at the back, which is fantastic. If I just enlarge a little bit and I'll get it more into the center. Yep, good. Okay, now I can see that the texture actually surrounds the whole head, which is good. Now I'll convert back to poly. If you put a texture map on your object and then you convert to editor properly, the texture map is saved inside the poly object, which is great for when we want to re-edit it. Now I'll go in and edit the unwrap UVW, and I'll go into edit, and there's my map. It's done. So I'm going to edit. What am I going to do? I'm just going to change the cylindrical texture. This is the head that's made. That will do for what I want to do. I choose select element and let me reduce this in size a little bit. See that I've got a couple of extra bits there. We'll see what those are afterwards. And I'll reposition my head. So always get it inside that square that's the thick one, because that's the render. So render UVW template, render. And there's my image. There's a couple of artifacts, I don't know where they come from. So let's save that. I'll just call it det, which is French for head. And I'll do it as a JPEG. There we go. It's done. There's my head done. And there's my unwrapping done as well. Right, now I'll go into my paint package. So I'll go and find the image. So tet, there you go. What I'll do now is always the same. Select it all. Control C, Control V. And it's now a layer. The canvas, I'm not going to touch it for the moment, but now I'm going to import a texture that's pretty much prepared. Okay, so in Painter it's place, and I'll choose this image. Okay, and there it is. Now, if I look at this image, reminds me of someone. If I look at this image, I can see there's the face, and there's the spreading out at either side. So let me put it underneath the first layer, so that we can see it if we make that first layer a bit transparent, and that allows me to move the image around to make it fit better into my unwrapping of the UV. Okay, this image, no problem there. Obviously there are control handles, so we can enlarge it a little, and it's now for us to put the deformation back on in response to the wireframe, which is my UV unwrap image. Okay, right, so we've got 2 or 3 little things there. It's not going to be perfect, but it will do for what I want to do. Okay, let's turn that off. And I can see that I want to make that one a bit transparent as well. Let me have a look at it as well now. I can see that the ears aren't very well placed because they start going into the hair of the beard, so we'll get rid of that, shall we? So we'll take the brush, we'll paint on that layer there, and we'll take the eyedropper, and I'm just going to rub over the beard so that get rid of it and show the ear through. And that's going to exactly correspond to the texture of the ear. Move over the other side. I'll do the same thing over on this side. Let me put the transparency back up to 100% to see the damage I've done. Okay, let's enlarge the brush. A bit bigger, and reduce the opacity a bit. So here's just a quick training so I can show you how we do it. To remind you that if we reduce the transparency here, we can see that there are bits in the wireframe that aren't actually covered by our texture, so above and below. So we need to fill those in, like so. The best of all is, of course, to clone the texture into these areas, but I'm just painting over it roughly. There we go. Same thing on top of the head. Oh, and that one as well. I'll give it a colour. Okay. Right, let's choose certain areas. Just here around where I've painted for the ears and the throat. And let's soften them to make them blend in a bit better. Okay. Same goes for up here. Ear, nose and throat? No. Okay. That's what I'll do again. So, that'll do. Okay, we can go back in here and look better at this later on. I hope so anyway. This is just give you an idea. This kind of work will allow you to already do lots of things. And let's just correct this here, it's just bothering me. And that's a better blend. Okay, right, let's save this. And just call it, just copy over that one. Exactly the same as with the hands. I'll go back to Max now. And I'll put it on the head in diffuse. I'll find the bitmap that I've just made. Open. I asked to see it, and there you go. Now we're going to correct it. The texture is put on there. We've got several artifacts. The position of the lips isn't very good. There's a couple of errors in the colours, and we'll correct those things. First step, to apply the image, unwrap our UV texture for a head. That's great. We'll go on to the second stage. So how do we correct these little problems, these little errors, these artifacts? Well, all we need to do is go into Edit. There's our texture, or we can pick it now, and we can go Bitmap and load it, or we can go Material Editor, or Scene. In this case we'll go into Scene, and I'll just choose my head picture, TET JPEG. That one, yep. There we go. In the options, I've got lots of different things. I've got constant update, which allows me to see it in real time, like with the brick walls that we saw earlier. Tiling is the repetition of the texture. I don't really need that. And brightness is the brightness of the texture based around the wireframe, which we really actually want high in this case. Let me turn off the selection of elements, and I'll turn off options as well. Now I'll get a bit closer to my UV texture, and I can see that I was completely wrong with the position of the lips over the mouth. So here we go. So I can take a point, but if you take 1 point, then it's going to be difficult to understand what you're doing. So let me put myself in soft section instead, and now I move all the points, and I can adjust directly on the mesh the position of the lips until they're right for my mesh. It's better. And that works also for all the zones, to correct them or to give it a bit more personality, to just adjust your UV map. See, the nose needs adjusting. There we go. Alright. There we can see the seam, which is at the back, which is the kind of jaggedy line up the side of my image. And let's reposition the beard a bit. And there we go, that's pretty much good. That's done for the position of my UV map. So now we can convert the head into an editable poly like that, and now we'll find our character with the texture adjustments needed. Okay, so that goes really fast, and it allows you to have an effect that's okay for a secondary person in your scene. Relaxing encounter, or more precisely, an encounter with relax. Okay, let's have a look at how it works. So there's our mountain. If I look at the segments, if I turn on F4, I can see that they're all stretched out. What is that going to give us? When I give us a texture, like a checkerboard, and I see it, oh, actually if I put a checkerboard on there, and I ask to see it, I can see that it's stretched. If I use tiling, if I do 10 by 10, then we can see that the mountain stretches out the checkerboard texture. So what we're going to do is look at an application of the relax tool, and then we'll go back to our head. Let's turn off the segment view, and now we'll go into unwrap UVW. I'll go into edit, and here I'll go into subobject vertex, and I'll just select the points here. Vertex. Let's select them. So vertex, and select them. They're the ones that I've selected, and they're the ones in the view. So let me reduce this view, and now I'm going to go into soft selection mode. I'm just going to blow it up a bit, the soft selection, so that I've got a larger area affected. Of course, you can use the paint select mode, no problem. In tools, I can see here there's relax. Relax, when you do it, start relax, stop. That's what you're going to get. That's not actually really good, so let's do Control Z. Let's change the stretch to 0.5 and start relax and stop it immediately. And like that, I can distribute my checkerboard a little bit better over the mountain, instead of the stretching that I had before. If I hit apply, it's done. And I'll show you how it looked before. If I turn it off, then you can see how the texture's stretched out, and now with unwrap UVW, look how it's relaxed. And like that, I can get the distribution of points that I actually want because of the vertices that are stretched out. So of course you can subdivide now. You go into Turbo Smooth, and that will look even better. So there's a use for relax. Now we'll go back and see how we can use it to correct certain areas on my character. Now we'll look at using relax on the face. On the face, we can see that there are some stretchy areas on the nose and on the corners here. So there aren't just those ones, but those are the most serious ones. So let's go back into UV coordinates, unwrap UVW, edit. And now I can select the vertices in the view, obviously, or I can just use this paint tool on the edit UVWs, which is perhaps handier. So let's paint here, and I can see which vertices are selected in the viewport. Soft selection, and I'll just bring it up like this, and let's just make it a bit smaller, the area. Let's zoom in a bit more so I can be a bit more precise. There we go. Now I'll test my relax on this bit here. So I can see which points are selected in my viewport. And now I'll go Tools, Relax. Let's change the stretch to 0.4 maybe. Start relax, stop. And look at the mistake I made. Okay, but that's to show you, obviously. I did it on purpose. We'll do Control Z to undo it, so that we come back to a more interesting state, and apply. Now, let's have a look at these bits on the corners of the nose. I'm going to reduce the size of the soft selection, and I'll do a relax. And then that way the face is no longer quite so stretched. That's better. A bit more. There we go. And we'll do this on the other side as well. And there we go. And now we've relaxed our UV. So that's fantastic. We'll apply, which allows us to find the texture or redistribute the texture a bit better. Okay, that's one of the bits. Okay, now I'll go a bit further. This is only the diffuse channel, obviously. Textures, obviously, you've also got to do luminous and bump and others. And you can still use the same image that you've already done, which allows you to add areas that glow or don't glow, like the shininess of skin where it's more greasy, or tired, like the bags under your eyes. That's what we're going to see next. A little reminder before starting. Starting what? Before seeing in detail how we do the textures of the face, like I promised you before. Okay, what I'm going to do is I'm going to use an image that's well known, this fence, which is in the wood section of 3D Studio Max. It's delivered with 3D Studio Max if you did install the whole thing. So this image I've also converted to grayscale, and I've upped the contrast a bit. With two images, I'll show you what I can do. I've put this image directly onto a box. That's pretty simple. And it's just got light there, and there's this box. So it's just a box with a standard light, a standard anomaly light. This image I've just put in the diffuse zone, as you can see. Now when we do a render, this is what we get. Okay, well, it's just exactly what you'd expect. Okay, now we'll go down to the maps and we'll choose bump. And we'll pick another image. We'll choose our grayscale image. And we'll do a render. And there's the relief now. There's the bump. Now we'll have a look at the previous one for comparison. Let's turn off the bump. And let's do another render. There you go. Flat, and there's the flat, and there's the bumps. And without the bump is there, so you can really see the bump acting there, whereas here it's more or less flat. The strength of the bump depends on the brightness of the grey. Right, and also on the value of the bump that you put here. Let's turn it on again. If I make a reaction to the light now, specular highlights. So this is something that's interesting as well. This is what I get. The light is put everywhere, even in the dents as the flat bits. So even in the mountains and the troughs, the peaks and troughs. This is not possible. This now looks like just a moulded flooring. Whereas when you use a bump map, use the same image, either in specular level and or in glossiness. If you put specular level, and this is what you get. Okay, the spec is filtered by the grayscales in your image. If I now swap it over to the glossiness with the swap, click on the two people, so we can delete that one, and I can see the two things. And now, look, what's happened? When I put the image into specular level, then the specular level, the bounce of light, there's my light there, and the bounce of the light is filtered by the grey levels. If I put image in specular level, then you'll have an effect that's a lot older and more used. However, if you put the image in glossiness, then you can see here, let's just lower the specular level. This no longer filters the specular level, but rather the glossiness of the bounce. Now we can see that the light really spreads out here, but the quality of the bounce, as you can see, is not filtered, because there's nothing in the specular level. It's the glossiness that's filtered, which allows you to work much harder on the sensation of the bump. Of course, you can put it in both places at once, and it's now up to you to determine the percentage. So we can drop the specular level here from 100 to reduce the influence of our grayscale map on the specularity to get a more shiny look. And obviously we can also reduce the influence of the glossiness map. It's you to play with this. It's your choice. Okay, here you go. Simply, just with two images, the same image in grayscale or otherwise. So now I'll show you how to do the same thing, but with our face, so that we've already seen, and all these techniques that we've looked at. As promised, now we'll look at using grayscale, colour and other layers, but all on the face. And this time we're going to use the cartoon face, the one that we already used as an example. Here we go. So what I want to show you, all these things, and here I've got UVW mapping here. So this is just the standard cylindrical, the same as I did for the head. Afterwards I've got the unwrap UVW. If I go into edit, then we can see exactly the same mesh, but obviously because it's a cartoon face, it's a lot simpler. It's a lot less heavy on polygons. And if I go into Turbo Smooth, everything's going to follow, obviously. So everything I've shown you before. However, we're also still going to look in the material editor. In the material editor, we can see there's lots of materials in grayscale or other, in lots of different maps. So we can see specular level, specular color, bump, and the diffuse. So if we look at the diffuse, sorry, not the diffuse, the bump, sorry. So we can see that the bump is just a grayscale image. And we can see all the little holes in the skin and everything are in grayscale. So let's carry on. And now we'll look at what filters the image on the specular level. So there you go. It's pretty much the same as the bump. It's a lot what we've already seen with the using the grayscale images with the planks of wood. However, the diffuse level of texture, that's a lot more rich. Now that's in 16 million colors, and we can see the JPEG here. And this is going to give us an interesting aspect for our cartoon, because it's half cartoon, half realistic because of the textures, but obviously the modeling is a lot more cartoony. So if I have a look in the materials, what do I see? I can see different things. I can see here I've got my diffuse image, which is in RGB in 24-bit, and it's in colors. All the rest, all the others, so this one, specular level, specular color, glossiness, this bump, they're all RGB, but they're grayscale. So NB, which is French for black and white. So these are levels of grey that give more or less force to their components. So let me turn on the diffuse and ask to see it in the viewport. There we go. There's the diffuse texture on my character. If I do a render, here you go. So now I'll add the other filters on there and the bump, which will give us a little bit more interesting character now. So there are the techniques applied to a cartoon character to give you a really more realistic look using all the techniques we've used up until this point. So first approach to tools that will allow you to stitch together parts of UV maps that have been unwrapped. Okay, so for this I'll just make a box. There we go. And I can add some segments there to make it a bit more complicated. And now let me convert this into polygons. Okay, this box, I'm going to add the modifier unwrap UVW, and now we're going to go into all the faces and select them all, Control A, and now I'm going to go into put a box texture on them. Okay, now I'll go into edit, and there we go. That's our box exploded, well, unwrapped. Put a box texture on it, so by face I should have 1, 2, 3, 4, 5, 6 faces. However, 6 sides is completely normal seeing as it's a cube, but let's select elements and I'll try and take one. Let's turn off face and let me try and take an element. Okay, the problem is that you can see that the texture is completely one level on top of another. They're all welded. So it's not like at school where you cut out your shapes to make a kind of cross to represent a cube that's unwrapped. You could perhaps do it by faces, so because I subdivided, it's going to make it a little bit awkward. So let me try and take these ones now. Here we go. These ones. So let's multiply my selection like this. Why didn't I just do a plane rather than a whole box? Okay. Right, there we go. Planar. And now this one, if I quit selection mode, I should be able to move it out of the way. So there you go. And now all the others. Now they're all detached. So now, yes, but no. We'll do other things. So let's select them all. And in mapping, we've got here normal mapping. So in normal mapping, the window that opens, it will use different presets that were already made. Back to front. So there, back to front. Carry on there. Let's go in there and do box mapping. When I do box mapping, now I find that I've got all my faces separated, all the 6 faces, and I'll see that in the scene it's exploded. Okay, so here, normal mapping, I've chosen box mapping. It's up to you now to say, okay, that one's the top, and that one's, oh, that's, well, that underneath there. And then, well, what about this? No, well, that's not very easy either. So, to sew them back together again, let's not go into select elements, but into points. Let's select this point here, and then that point there, and so on, and I'll do a multiple selection. And what you can see that's interesting is that there's another part of my UV map up here that's also modifying. So why is that doing that? So I selected this one, and then this one, and this one, all the way down the line, and then they were also selected here. 1, 2, 3, and so on and so forth. Selected isn't really necessarily the right word, but they are the corresponding points. Once the points are selected, right mouse button, stitch selected, and you will weld those two together. You'll stitch them together. Let me show you again, Control Z. So the points are selected here, stitch selected, and automatically they're selected and are stitched together. So if I take these points here now, so the ones I need, so now I can see that face there. If I do stitch selected again, right mouse button, so I'll continue in the same way, choose those ones, stitch selected, and again, here we go, stitch selected, and now one more. It's a little bit faster, isn't it? Stitch selected. So now select elements. So let me take my whole cube, freeform gizmo, and I can scale it to fit in my UV space, and there we go. Now for me to use tools render UVW and render UV template. If you don't see the image very well, don't forget that you've got to zoom in. It's just because of the screen resolution. Okay, like this. We can now continue to make the cube, which is what we're going to see next. Okay, so in my paint package here, I made a layer here that shows. So let's hide that one, and I can see my dots for my dice. So always number 7 that goes on either side. So 1 and 6, 3 and 4, 7, 2 and 5, 7. Okay, so I'll save that one as cube, as the JPEG, and I'll call it cube bump, and to do the bump mapping. Okay. Quality hide, that's fine, you know that already. Okay, so now let's do other things. Let's flatten all this. It's only just in a single image now, and I'll go in here and I'll do a negative. Obviously, your paint package will have different things, so let's modify a few things. So let's change the color. Let's, or instead of the black, I'm just going to do a color. I'll do this kind of yellowy color. There we go. And then change the color of my dots, and let's change them from white. Okay, that's good. That's going to be my diffuse map. So I'm just making it a little bit more interesting in the color. There we go. And let's do a little bit of blurring on them, soften them. Okay. Alright, that's my diffuse map. So we'll call it cube diffuse. And this one I'll put in high as well. Right, I'll go into 3D Studio Max. And I'll take my material editor, put on my diffuse, I'll just put the colours there. Just take that one. I'll ask to see it. There we go. Now in bump, if I go into maps, go into bump and take bitmap again there, and then take cube bump. And I've got it there. And I'll also put it in specular level, so filter the levels. So I can already see the result there on the sphere. And if I do a render, there we go, that's what I get. Okay, let's subdivide it a bit so we can see what it gives, a turbo smooth. And the cube was already subdivided, remember, so we're good. I don't have any worries. Good, rapidly. Very rapidly. A little dice thing. And there you go. Okay, well, we can actually see a few other things here, and don't forget that with the new 3D Studio Max 210 we can see these things directly in the viewpoint, and we'll look at that in a moment. Right, as promised, we're going to see one of the new things in 3ds Max DIS, which is quite useful, which allows us to see, in hardware rendering, several things in our viewport. Now the goal here isn't just to see the new things in 2010, but the help it will give you to be able to manage your textures, which is the whole point of this little training. So let's duplicate my dice, turn it a bit so it's a bit different. There we go. And now I'll make a plane for the base. This plane, I'll make it a bit bigger and move it to standard lights now. So Omni, there we go, and I'll look at its intensity. I'll put up a bit more, obviously, and just copy it over here. This one, I'll make sure it makes a shadow. There we go. And the one behind, put it a little bit lower on intensity. When I do a render, this is what I get. What would be nice would be to be able to see the same thing in the viewport, to be able to see the bump map, for instance. To do this, first of all, let me change the blue here. I don't like it, so let's just go to Material Editor and put a grey on there. That's better. Okay, that's good. And now what I'll do is just go into Hardware Render. So Shift F3. When you do that, you can see a plus HW there, which means that you're now in hardware rendering. Okay, now we're going to ask that the texture used on the dice, and just them, that's the only texture we've got, are going to take into account the hardware renderer. So to do this, on the front view here, click on the front button with the right mouse button, and I'm going to go to Extended Viewers, and I can see Material Explorer. So here I can see standard no maps. Okay, well, I'll change it to hardware maps, and now we can see the difference immediately. Let me just look back in standard, no maps, and now hardware maps, and we can see the bump of the render. So to go back to the front view, just press F on the keyboard. Okay, now I'll ask also to see the shadows, so right mouse button on there, light and shadow, configure. I'll hit enable shadows and soft shadow. Okay, and now I've got the shadows just like in the render. Like this, I've got it's much easier to work and be able to see directly whether my bump is right or not. When I go into the material editor, then I can change the strength of the bump. Here's the bump. Let me reduce it, and we can see it immediately that the bump adapts in the viewport. I can even take it to minus, so we have the bumps extruding out of our shapes. So we can see that the bump is adapting automatically to what we're doing in the material editor. This really helps workflow. Of course, also specular highlights, we can do those. And we can see, like that, we can see how the luminous aspect of shaders is controlled, and the placement of our textures, and how we push hard on certain elements in our viewport. So here's a little bonus in 3D Studio Max 2010. That's a big feature. Okay, so we're going to continue with our normal mapping. Does Max propose others? Well, here's a beautiful bit of clothing. Let's put a texture on it that just checkers on it. And ask it to be displayed, and just up the tiling. If I put 10 and 10 for repetition there. Okay. Now we'll put modifier UVW unwrap. Let's take all the faces, Control A. And now I'll go into edit, and we can see here the options, mapping, normal mapping. Back front mapping, okay. Well, that's exactly what I want automatically. That's the front and the back of the shirt. So how does normal mapping work? And all these different things in the drop down menu, like back front, left, right, top, bottom, box, no top, box mapping, diamond, normalize, rotate, and align by width. Let's have a little bit of a look at these things, and we'll try and explain. Let's turn off unwrap and go into perspective view so we can understand a bit better. And now we'll do a little bit more drawing. So the general principle is to close the object in a bounding box. This bounding box holds the entire object. Okay. It's a lot easier to understand now that what we mean by the different options there. Front, back, there's top and bottom, and obviously left and right. So automatic unwrapping for box, we did it with the dice before, and box no top, it just means that box with no top. The diamond, okay, diamond is a little bit special, and basically rather than being a bounding box, it's kind of enclosed in a bounding diamond, and each face will be unwrapped for its texture coordinates. It gives us some things for certain shapes. It's up to you, you know, depends on what you need. So let's have a look. We'll go into edit. Let's select all the faces, Control A. Everything's in red there, so normal mapping, and now we'll go into diamond mapping, and it's surrealism. There we go. Diamond mapping will give us this kind of thing that's a little bit bizarre, in this case, in this clothing. So for this clothing, I think probably back front is probably the easiest way to do it. Okay, so what are these options down here? Normalize, rotate, and align. Well, it's for making sure that your unwrap takes place as best as possible into this UV space. The easiest is if I draw again to show you. Amongst you, there will be people who've played with scale models, airfix models, and you'll know that all your images are applied on a little zone with decals that you dip in water. So here's our image with our scale model. It's a 2D image on which we put we can see some stickers. These are the sort of logos, illustrations that we will put onto our scale model, on our 3D scale model. 3D model you've obviously made with the plastic bits and the glue and all the rest of it. Same in Max, really. Here's the image. The image that's on here that we put onto our 3D model, which is a scale model of a famous piece of clothing. Well, not going to stay in the middle with a great big empty space just because the image is just in the middle. Not at all. These take up less space, or take up the least space possible. And if all your little stickers or clusters are taking up as little space as possible, then if your shirt is at an angle like this, then it's after it will leave the image like this. It's better to put it straight because it takes up less space. All this will take respect a certain scale. That's what I'm trying to say to you. Let's have a look. Normal mapping. Normalized clusters means all the clusters will be at roughly the same size, same scale. Rotate clusters will allow you to optimize to get space, and spacing is the spacing in between each cluster. Okay, so quickly, that's how to understand this. So it's pretty important when you want to keep some space. So we're going to see it now in a different way, with a different technique, a technique that is more suitable for rounded bodies. That's what we'll have a look at now. Okay, so we've looked at planar projections, which are great. We've got cylindrical for a face, and for rounded objects, hey, I'll use a teapot. So all this teapot, I'm going to look at this round body of the teapot. Okay, so what I'm going to go is do I'm going to put a checkerboard on its surface so we can see the deformations involved. You can also obviously create your own texture, and sometimes it's even more interesting to do that with numbers or whatever. Here I'll do the tiling to 5. Some people use squares with circles inside and numbers to understand repetitions and so on and so forth. And that's up to you, obviously. Okay, here's my teapot. I'm going to do an unwrap UVW. And now I'm going to go into Edit, and I'm going to use Flatten Mapping. What is Flatten Mapping? Of course, we've got to select all the faces, Control A, and now I'll do a Flatten Mapping. Okay, Flatten Mapping is to flatten out your object, and we'll find some strange menu items, so like face angle threshold, spacing we've seen, fill holes, don't know what really these are. So let's start by drawing, as usual. It's a very simple concept. Right, for rounded bodies, it's not easy to make a texture. In fact, it's pretty much impossible. I defy you to actually completely flatten a ball and be able to rejoin all the logos that are on a football, for example. So we're going to use the same principle as taking an orange and peeling it. So here we go. Here's our orange, and now I'm going to do imagine trying to take off the peel of my orange. So I'm going to do my central axis here through the orange, and I'll give it a cut with a knife, which will allow us to cut out a section. I'll turn the orange a little bit, or turn my knife, and then I'll do another cut, like that. That will be selected, and I'll continue like that to do different areas of the orange, like that. This is something that's pretty interesting, and what I've done is I've turned it around an axis in the center of the teapot, or orange. But this is a little bit like how we represent the Earth. If I take a map where we've got all the continents presented in the center, obviously the line in the center, there's no deformation, but there are errors away from the central line. There are more and more errors. So if we want to be accurate, we need to present the map in this fashion, all completely cut out. So in the center it's still attached. This is a bit like what we're trying to do with the textures, remember? And here it's cut out with the North Pole and the South Pole and the other continents, which will allow me to have a correct size and no deformation, and to be able to put it back on the object. Well, that's what flatten does. Okay, so the menus don't hold any secrets now. So face angle threshold, that's how much you turn your knife around. Spacing is still the same thing for the clusters. Normalize clusters, rotate clusters. Normalize is so that everything's at the same scale. Rotation is so that they take the least space possible. Fill holes is so that the small clusters go inside the bigger clusters. We'll leave it at 45 and we'll do okay. And here we go. There's my teapot. It's all completely exploded. And now you can see all these little bits are inside bigger bits. Okay, let's start again. Let's select it all, Control A, flatten mapping, and now let's turn off fill holes. Okay, and there you go. Now these holes are not there, but all the bits are around the sides of the teapot. Let's Control A again, flatten mapping, and I'll take off rotation. Okay, and so now we can see the spout, which is here. Select elements, and we'll do so. There's the spout, and it's still got the same rotation as in the viewport, which means it takes up more space. I can see that the rotation is not horizontal. The same goes for the spout. It's the same as in the viewport. If I start again, and I'll keep rotation back on. Control A, obviously, for everything. Flatten mapping. And now I can see that the spout is horizontal. Same goes for the handle. And like this, we've got different options here. Don't touch spacing or put tenths, because otherwise you'll have enormous spaces between your objects, between your clusters. I'm going to put 90 degrees for trying out something here. I'll hit OK. And I'll do it on all my elements, obviously. Flatten mapping, 90 degrees. And I hit OK again. Right. So now I have two sides of my teapot. And the body is cut at 90 degrees. And the other bits are spread out at 90 degrees as well. But the top and the spout, I don't really need to do this 90 degrees. This is good for the body, but I don't need for anything else. So for the other bits, I can use more traditional types of map, like cylindrical or planar. That's what we're going to look at now. So our brave little teapot is really the ideal object for continuing our discovery of flatten mapping, etc. So let me just take this top. I'll just hit plus until it's all selected. What's happened? Since then, there's no vertex in common with the rest of the teapot. The whole thing is selected, and now I'll just do a planar map on it. Let me just resize it with fit. Now I can see that the mapping is on that teapot top. Okay, this element here, let's select element and hit. Let's turn off the mapping, and now let's place my element in the right place. So do that. There's my teapot lid, and it's over there. That's fantastic. Okay, now I'll go down to the body. I'm going to put the teapot over here, and this part of the T-bot over here. I'll go back into vertex mode and I'll select one vertex here, and we can see where it's red point in the viewpoint and the corresponding point is blue up here. So you've got several techniques to select. So we've got tools like sketch vertices that will help us to select just by holding down the mouse button down a line like so. And now you've got a kind of a marker thing. So click with the left mouse button and go down and draw a line. And the line is where your vertices will be placed. And now you've got a straighter line for your texture. So Control Z and I'll start again to show you. So sketch vertices. I'm going to click on them all one by one, sliding my mouse button held down over them from the top to the bottom. Now here, I can draw them down like that. And you can see that after a certain time I can just put them where I like by keeping the mouse button held down, and you can see that it's based on where you move the mouse. So I made an error there, so let's just start again. Sketch vertex. There we go. If I hold down Alt and just click, and now I've clicked, and now I've got a straight line automatically, which is a little bit better for our purposes. These ones correspond to here. So if I do sketch vertex again, and what we're trying to do in this lesson is cut down on the amount of distortion there is in our texture. So I hit Alt before I click once and drag it down, and there we go. And now they're more easily selectable, so I'll go into Stitch Selected, and there we go. Now you can see there's a lot of distortion, but it means that at least the textures are joined. And we can see that there's a little problem here with distortion. So I can select this point and do a loop. If I do an edge, it'll be easier. I do a loop, and now I can click on Align Horizontal. And now you can see that the line has become horizontal. Control Z. So if I now select certain segments like that and do select loop, and now horizontal, and that doesn't really work because it puts them all into the same place horizontally, obviously. So we've got to do them one by one. Loop, loop, align horizontal. Alright, so now we've got a vertical or a horizontal line. So if I take this, that's ring. So if I now do vertical, they've all become straight. If I do loop and vertical, but they're the same place, so we need to take just one at a time. So this is not a technique that really interests me here. So as per usual, I'll put myself in vertex mode. I'll just click on the vertices that interest me. I hit soft selection. I'll enlarge my soft selection. There we go. Even take a few more here. There. I can see in the viewport what I'm doing. So that's soft selection, as we've seen but lots of times before. And now I'll go Tools, Relax. Start Relax. And now you can see that my squares are a little less distorted. In this case, Relax has reapplied my texture. Obviously, if I select the whole element and I do the whole relax on the whole thing, I do relax, and this is a bit too strong here. Stop. Control Z to undo. Change the stretch. Start relax. No, that's even worse. Control Z. So we can keep boundary points fixed, and we'll do relax just in the inside. So this option is very interesting. All the exterior points are fixed, and I'm just doing the relax on the inside, and we can see it's worked kind of. Still using vertices and soft selection, I can take and stretch the points up, or move them, or adjust them as I like in my view. This is one of the tools you've got, so it's practical for reassigning textures or moving them around, stopping the distortion. There we go. To put textures correctly, we can see that there's a little bit of a problem here. So we can see if we can actually weld some points here. So if we select one point, and I can see its corresponding point on the other side. So we do target weld, and we can just drag and drop. There we go. And automatically the cursor changes and your points are welded, which allows us to correct the position of our texture a bit. Target weld, just drag that in there, and so on and so forth. So let's soft select these points in the middle again, and do another relax on them. Okay, let's now go on to the spout. For the other parts of our teapot, like the spout for example, what I'll do is go into my scene and directly select them here. So I'll turn on ignore back facing, select by element, and when I do that, now everything I select, all the spout elements are selected. Okay, so I think that cylindrical will suffice here. So let's just do that, and a fit, and now let's align it manually, rotate. There we go, and we'll do another fit, and now when we do that, that's an automatic fit for our spout. I could also have selected my line for the handle, for example. Okay, now I've got different elements. Let's change scale a bit there. It's not complicated, you just need to quit the projection mode and then you can change the scale and put it where you like. And now we can see that we've got lots of elements that are outside our renderable zone. Okay, so here's another little tool that's very handy. So we'll go to Tools, down at the bottom there, Pack UVs. When you do that and you do OK, you're going to realign everything, and it's all going to fit into the same space. So it will take them all, and now we'll do Pack UVs, and now it realigns everything so it fits inside the render area of your UV space. So we've already done that, and we go to Render UVW Template. And like that, that allows you to redistribute everything with all the spacing for the clusters, etc., and have an image that will correspond to the render. It's not perfect, obviously. It's just a starter guide, just to give you an idea, all the basics and all the tools. So after that, it's up to you to learn. So here we go. What we've seen in Unwrap is now, this is really going to help you. We've gone from a basic object to a character head, and I think that's pretty good already. So now we're going to continue now with other things, other techniques. We'll see now what we can do with texture placement, and also, do we always need to make UV coordinates? There are materials that don't need this, so that's what we're going to look at next, all the time in this. Other tools that could help you. Okay, we can see my editable poly object, and we can see its segments. So F4 to show the segments. And now what can I see? My texture is a little bit stretched in different places, and there are some problems with the placement of the texture on here. So we could try and correct it a bit. In Unwrap, we don't do anything, okay? We're not changing subobject modes or anything like that. All we need to do is go down to Tweak, and now that allows us to take the edge that I want to, and I can just pull out the texture as I like. This allows me to try and correct some little details. What I can also do, since it's based on the segments and vertices, so could I have more finesse to correct these problems if I put subdivision on my editable poly, over my editable poly, under my unwrap. So I put turbo smooth on, and now where I can correct a lot higher resolution, if you like. This is great for some things which are badly done by globally, but more it's actually kind of a way of hiding teeny tiny problems. But like this, you can actually put your textures in better places, which is quite useful for some things sometimes to tweak. I'm not moving the mesh here, okay? I'm using the mesh as a guide for moving my textures. Okay, so that's pretty useful. If I come back to my polys, I would get rid of turbo smooth. I go back to my object. The texture is assigned to the object, and if I take a polygon now and move it, now I can see the texture is actually moving of the mesh. So I'm moving a vertex, and you can see the mesh is moving and the texture is trying to follow. This is a bit awkward for when we just want to tweak our mesh or do other things. So in this case, you have an option. If you come down here and you come down to Edit Geometry, you've got Preserve UVs. Now, what it will try and do is keep the mapping in the same place. It will try to anyway. So you can move your mesh around a little bit. You're a bit limited in your movements, but as you can see, it's pulling your texture map a lot less, so it allows you to add some things as well. So if I take this polygon and I delete it, delete this one, delete this one, delete this one, and there we go, delete those ones, and now take the borders, and now I do a cap, and I can see now I've got my UV texture in there. Okay, I can even say, for instance, do a cut, and the UV mapping coordinates will try to stay as they were before, even with all the anarchic modifications I'm trying to do. We'll come out of subobject mode, and we'll go back to tweak, and we can see, we can try and make the best of what I've done here. Obviously this is just daft, but using tools like this will try to preserve your UV coordinates. So if you're changing your mesh, don't forget to tick Preserve UVs, so Max can try to keep your UV coordinates correctly recorded in your object's topology. Another technique that's well liked, for good or bad, is pelt mapping. So pelt is basically like stretching out skin. Okay, I've promised to show you, and here we go. Here's my cartoon character. The pelt needs segments. So another little thing to remark here is the mesh here. Often I actually put subdivision on after I've done my UV unwrapping, and subdivision is done on top level after my skinning is done. So here, let's put unwrap UVW here, and now let me go into edge mode. The segments I want, let me see them with F4 on the keyboard, and I've done a checkerboard there. So let's also just change the color of my cartoon character to make it a little bit more obvious, so we can see a lot more on video. Okay, right, point to point. So when you do point to point, what you do is you select a point and you choose another point, and the loop between them is going to be selected. So here and around to here, up to there, like so. Okay, and now we've stopped the selection with the right mouse button. So selection is done. So now I'll go into face mode. I'll pick one face inside or outside, in this case interior, and I'll do exp face cell to seams. Expand face is selected to seams. There we go. Everything is selected now. That's really handy. Now, like this, I've just got this part that's selected. This area of my UV map, I'm going to pull it out like the skin of a rabbit on a round former. So when we click on pelt, this is what we do. We can see the stretching that we're going to do there. We've got pelt options that allow us to straighten the stretcher. We can select the whole stretcher, so we can change its tension, or we can select the pelt UVs that we're going to pull out. Lots of different strengths and everything. So, okay, so we'll come back to that. Here, I can start pelt, stop. Automatically, it's just pulled that skin out towards the outside edges, towards the stretcher. So if you do a reset, it just goes back to the start, obviously. Let's just drop down the number of samples. Let's do a start pelt and stop. And we'll do a relax and stop. And result, what do we got? So now we're mixing the different kinds of relax there with the same functions that with the relax we saw in the tools menu, and pelt. The pelt is being done based on this stretcher circle around. Automatically it's going to be a circle. To choose this, we'd hit commit, and now we've got our face completely flattened out, which can be very handy because that will allow me not to have to do a relax on the nose or whatever. It's up to you. Let's have a look now if we apply the checkerboard texture, and we'll see what it gives. And there we go. There's a pelt distribution. And in this case, it's pretty useful. There's very little deformation on the side of the nose or whatever, like I had before with my character. So you're going to be asking me, why didn't you show me this to start off with? Well, because there are lots of different techniques, and now at least you've seen them all. Okay. Now we're going to have a look at other little things with the pelt map. Okay, pelt mapping options now, as promised. Okay, here's my selection, and there's obviously a selected element, or in face mode, and in pelt. And so we go in here, that we can see this circular stretcher for our skin. In pelt options, I've also got snap to seams, and what that does is, rather than being the circular border, is going to be snapped completely to the cutout over the face. If I now select my stretcher, I can scale it up and just spread it out from my original shape. Now when I do a pelt, instead of pulling my face out according to a circle, it's going to pull it out more in line with its settings. So let's start and stop. And this can sometimes help for giving fewer deformations. So relax. And I'm relaxing the stretcher at this point. It's up a bit, and so on and so forth. The relax is done on the selection. So here I'm doing it on the stretcher. So select the pelt UVs, relax, and now the relax is being done on the UVs themselves. So there you go. It's pretty easy to understand now, especially since we've looked at lots of different steps. If I do commit, now I'm going to say OK to my modifications that I've done. Now, like this, I can modify the textures or whatever. Now we're going to have a look at the axes for objects that are much simpler, so we can understand a bit better. Here's a little exercise that's going to show us 2 or 3 options in pelt mapping, and 2 or 3 other little things that for unwrapping a UV. So here's a torus. We'll convert it to polys. There we go. Turn off the grid. I'm going to put the unwrap UVW. I'm going in here into edge mode So we can see the edges. I'll hit F4 and I'll choose this edge like this and one that's in the other direction. So there's a bit of a kind of a right angle here. So I'm going to go hit loop to extend my selection, and now I've got a cutting out of a sleeve of a shirt, let's say, that's been put into a loop. And let's cut this bit out and that bit out, so we can see that this is seams. So we'll do edge select to seams there. And now if I go back into face mode and select a face, this is to use the same techniques we did with the face. Now once that's done, we'll go into pelt, and we can see, oh dear, yeah, okay, so let's do start pelt, and look, that's pretty good. Stop. So it's completely unfolded the object. The orientation isn't necessarily good. In pelt options we can go to mirror axis so that we can change how it's stretched out, and so you can change the orientations. Start. Sometimes it can really help. Obviously not here. Okay. Right, what I'll do instead is I'll snap to seams, and now I'll select my stretcher, the form that I'm going to use to stretch out my UV map, and I'll free form, and I'll change the scale towards the exterior, and now I'll do a pelt again, and there we go. Now I'll select the pelt UVs inside, and I'll do a little relax on them. Okay. And now let me take the stretcher again. I think we're pretty much doing all these the same things here, and I'll move it out a bit more. And let's see if I can turn my stretcher, rotate it around, straighten it up. There we go. And now we do start pelt, stop pelt, and like this you can see that there are sometimes much easier ways of getting the results you need. And readjusting your pelt. There we go. Let's hit commit, and now I can see all my lines that are not very well aligned. So let's see what damage we've done by putting a texture on here. We'll put a checkerboard, obviously. This one usually shows squares and what it does with the tiling here. So let's do 5 and in U and V, and here we go. And we can see that the distortions that are based on these lines here. So let's correct this very rapidly. We'll just go into edge mode. We'll take one line, any old line, that one. We'll do loop, ring, and then we've got all the horizontal lines selected. Now we'll do align horizontally, and there we go. And I'll do exactly the same for vertical lines. So take any old one, loop, and ring, and align vertical. And now we can see that I've got much better distribution on my shape. Okay, here's an exercise that's useful. It's complete for little tools that will help you to organize your pelt and distribution of lines and segments, and for better placement of your texture on your object. I could use it for another example perhaps, but like this you can see in a simple manner progressively all the different tools in 3D Studio Max to help improve your UV mapping. For the most part of this DVD, we've been studying applying textures and their UV mapping. The textures we've been seeing are 2D. Normally we'll use these 2D textures in our diffuse zone or whatever. For explanation of diffuse, ambient or whatever, just go back to the DVD about materials and lighting. It's not the goal here. What we're going to try and do is understand what a texture is and how it's placed. So normally we use 2D. So here we feed this area with 2D images. And that's what we've seen since the start. What's a 2D image? Very simple. It's something that's come from a scanner that's scanned in X and Y. Scanners, we'll say that everybody's got scanners. Okay, these pixels are encoded as RGB and are going to be placed onto a 3D geometry. It's not a scanner. Obviously, we're going to work in an image editing package, or using a graphics tablet, or using image editing tool to retouch a photo. But it's still always 2D. It's a bitmap. This bitmap is in X and obviously in Y. And once it's loaded into the diffuse channel, it's put onto the 3D. So there it's got deformations called UVW, and it will be tacked, if you like, to the object. And so it can be tacked to a 3D object and submitted to deformations, so U and Vs. So by tacking, we need to correctly place our points that correspond to the geometry and the picture, so that we can place our image where we want them. Okay, so far no problem. We already know we can move the geometry points to flatten out our geometry to see how we make our UV map, so like pelt and flatten and so on and so forth. That's 2D texturing, and there's also 3D texturing, which we can put in various different places, just like 2D textures. The place where we put our 3D textures is exactly the same as 2D. 3D textures, what are they then? So a 3D texture is not expressed in UVW coordinates, but perhaps in X, Y, and Z. And 3D textures are generally procedurals. Procedurals are based on the construction of your geometry. 3D procedurals often make stranger kind of effects, like marble or noise or cellular or whatever. So these procedural materials allow you to create odd looks, but they're not limited to the resolution of images. So when you zoom in or zoom out of your geometry, because these effects are in 3D, they will always be recalculated automatically. They're not subject to pixelization that you would see in a 2D image. They can't be pixelized because they're not made in 2D. They are generated automatically by the computer. This type of texture, 2D or 3D, are going to be here, 2D maps, 3D maps. If you do all, you can see all the different types of mapping that we can do. All the different types of textures, images, materials, whatever. 2Ds, there's bitmaps and checker that we've used a lot for our UV mapping. Gradient ramp we've used, not so much for the others. Go back to the materials to have a look at those. So 3Ds, so cellular, dent, so on and so forth. So what we're going to see now is the difference between 3D and 2D, and above all, applications and tools for using them. To remind you, 3D is based on the size of your objects and of your universe scale. It will be applied based on the size of your object, whereas 2D, it's you that stretches out or squishes it down, and that can create pixelization problems. The interest here is to understand how the 3D Studio Max is going to offer you two different types of texture, 2D and 3D. So 2D need UV coordinates, and 3D ones that don't, that will work on the geometry, and it's this difference that we're going to look at now. So let's have a look at the differences that we're going to see in 3D Studio Max. Here, let me take cellular in diffuse, hit OK. Now next to it, I'm going to do a 2D texture, so I'm going to choose a bitmap. I'm just going to find a bitmap on the hard drive, the ones that we've already worked with. Let's go in here. Okay, I'm not going to use it, I just want to see the difference. When you choose a bitmap, you're in texture mode, which utilizes map channel number 1. We've already seen this before. We've got tiling, offset, mirror, other things. Angle you can change as well, but go and have a look at that for yourself. So we already know about all this. However, when I come to the 3D texture, it's not allowed. It's directly applied to the object X, Y, and Z. I don't see map channel. I can't actually click on it because it's grayed out. I can't modify it. Okay, if I apply this kind of thing, this is what I get. When I do a render with Shift Q, I can see something, but I don't actually see it in the viewport. That can be a bit of a problem. 3D management. If I zoom in now on the object in the view, and I do a render, I've got no pixelation at all. I've just got the 3D components there, the 3D texture that's just zoomed in and it's generated automatically. I'll do another render, and there we go. So I get a slight blur or more detail in my 3D texture. It won't ever get crunchy. It will automatically follow the geometry I've made. The problem here is that I don't see it. I don't see it here in the... Now I can see it. Ah, look. Don't forget to click on show. So it corresponds more or less to my render, so that's okay. So I've got some other little things here that I don't like. I'd really like to be able to move it around on my object, how it's tacked to the object. So we could put a standard UVW map on the scene. I can see that it's in planar and I can see it's stretched out on the side, and it's not at all like I can see in the viewport. Okay, so it's giving you something that doesn't look like the render. Well, so what's the point of that? Okay, that's just for showing, and it's stretched out, but I don't see that. Okay, when you use mapping, so UV coordinates, channel mapping, etc., the things we've already seen, 3D doesn't care about this stuff, because a 3D texture here, its source, its coordinates are based on object XYZ. To change around, then what we can do is we can say explicit map channel, and at that point we're now working on the map channel, which is great, but now I don't get anything either. Okay, map channel number 1, that's a bit of a problem. Number 1, planar, and we don't see anything. What's going on there? We could go to XYZ to UVW, and then the 3D texture goes to the UV mapping coordinates, and it will be 2D deformation. That's important. When you do that, when you take a procedural texture, which we looked at earlier, 3D is X, Y, and Z, and I'd like it to work like a UV map, but UV mapping is based on not on X, Y, and Z, but is transformed into U, V, and W because they are deformations, non-linear space. I hope you remember. Okay. And here, if I say X, Y, and Z transforms into UVW, and at that point, I can use this tool to transform my X, Y, and Z into UVW for 3D textures. So now my 3D texture will be considered like a 2D UVW texture, and we can manage it. So in the next chapter we'll have a look a bit further, and as you can see, you want to be able to see it in this way. Now you can change without any problem the size and all the rest of it. Okay, let's go to trying to place it a little bit differently based on planar, circular, etc. So let's return to the management of 3D textures in 2D space using UV mapping. Let's come back also to two details. I can see that my box is 1.5 meters by 1.5 meters by 1.5 meters. UV mapping is there in 3D. And it's transformed into 2D. I'm doing that automatically, so there's no problem there. There's no worries about the size. You can see that the size of the cells there is generated by the cellular parameters down here. So we can see that it's 5 at the moment. If we go down to 0.001, so there you go. Let's not go so small. Let's try just 0.1, like that. Still too petite, too small. Let's lift it up a bit. And there we go. And now we can see here that the size of our texture is based on the size in our scale, in the material editor. But this means that you can't stretch your texture out at all. If it's based on this size here in Material Editor, then you can't drag it out on one dimension or the other. So your cells stay the same. That's the principle of 3D transformed into 2D, UVW. So let's have a look. I'd like to actually stretch them out if I can. Why not? Okay, so if I go into planar mode, well, that's what I get there. I get planar, let's put it everywhere. I'll try cylindrical. Okay, but we don't understand much better there. Let's change the size here now. Let's try 0.4. And now you can see you need to be really careful about the scale. So let's try back on the 0.1. And now I can see that cylindrical and with a cap is working fine for me. Here now I can drag out my texture in a cylindrical manner with a cap there. So down here I could actually go real world map size, and then when I do that, then it's in a real world map size, as you say. So that the size there is not stretched out but distributed, basically keeping the real size. So this is one of the pretty interesting functions. We'll turn on real cap and real world map size, and obviously cap doesn't work in cylindrical with real world, so let's try box instead. And now it's just going to keep the size of the mapping that you've done in the Material Editor and not the length that you preset in the UVW mapping settings. So it's your choice. So you can either base your scale on Material Editor 3D texture, and it won't be subject to UVW stretching. The size that's here is going to stay constrained if you use this option. You can globally select this option in all of 3D Studio Max. So if you go into Customize Preferences, and you can see down here, Texture Coordinates, use real world texture coordinates. So if you tick that, they're applied everywhere. So keeping your real world size of textures to avoid stretching, it's your choice. That would also stop you from being able to do creative UVW management. There we go, there's another approach for real world map size, and relative sizes, stretching for UVW, or be careful how you change the size here and how it will affect your UVW mapping. So can a 2D texture be transformed into a 3D texture? Well, let's react like a 3D texture. So what I'm going to do is make a teapot, and now I'll apply a texture, basic texture, diffuse in 2D one, bitmap, and I'm going to take my UVW one, and there we go. Now by default it's going to just wrap this image onto the object in UV coordinates. Okay, so we're not going to touch anything, but we're going to see texture, explicit map channel, and number 1 is there. That's what we've already seen before. However, you can change the mapping to planar from object XYZ, which is relative to the object, and there you go, world XYZ is relative to the world. When you see XYZ, you know that it's linear projections, and you know that it doesn't use UV coordinates. Let's take this instance, and this is what we get. Now what I get is a stretching of the texture based on the object. We're going to just hit render because sometimes it disappears. Okay, so we can see here the principle is pretty simple. The texture is here over the top, and it's projected down in a linear fashion, and it's being stretched based on the 3D object. Okay, let's go back and we can see it's actually updated. You can now work on the tiling, so you could use real world scale, but when you do that and you work in XYZ, so projection, linear projection here, which is no longer based on the UV coordinates, you're going to work in real world scale. So let's see a render to see what difference it makes. Not a lot. If we change, we can see how the texture is placed on there, and we can see that the size is down to 2.54 centimeters, basically an inch. Let's double it to an inch, to 5 centimeters rather. And now I can see that it's blown up. If I do 1 centimeter by 1, I'll halve it roughly, and I can see a repetition of my texture. And we can see stretching here. If, on the other hand, I want to have the mapping applied on all the senses X, Y, and Z, and not just relative to the object, then, at that point, I don't use planar based on local coordinates, but planar from world axis, world X, Y, Z. And there we go. Okay, now we've got another little problem here. It's very small. So let's turn off real world scale for the moment. If I turn it off, then you can see that the tiling is there, but if I keep it ticked, then I've still got just my 1 centimeter repetition. So let's just multiply that by 10. So instead of every 1 centimeter, we'll do every 10 centimeters, and let's see what it gives you. And there you go. So now it's a lot easier to understand. You know that the centimeters aren't relative to the object, but the world. So 10 centimeters of projections in all these senses, and that's based on world coordinates. And for some objects, this would actually be quite useful. In any case, this is how a 2D texture is based on the axes and linear projection of 3D. So planar from object XYZ, so it's a plane that's just projected onto the object, or planar from the world XYZ. If you tick that to follow real world scale, that's what you get. Okay, our teapot was very pretty, but are there any real world applications for this? Let's just try doing a little something. Obviously this exercise needs you to have seen and understood all we talked about on the materials and lighting DVD. So things we've already seen before in other training. So we're going to do something quite quickly here. I'm just going to make a plane. And let's see what I'm doing. It's a 3 meter plane. I'm just going to give it 20 length and width segments. Okay. And now I'm going to add a modifier, displace. Displace, I'm going to use a map image. I'm going to use a 3D one, which will be noise. Let's say, for instance, there's noise. Okay, let's load it in Materials Editor. And let's have a look at here as an instance. Right. What I'll do is use a displace to move my thing up a bit, and I can see that noise is working on the structure quite well. I'll put it in fractal mode. I'll change the concentration of the whites and blacks, and so more contrast there is, the more I get this kind of deformation. It's the whites that are going to make the deformation bigger or smaller. Let's change the size. Okay, very good. This noise, I'm going to put it in a gradient. So there we go. I'll keep it as a submaterial, and I'm not going to do a linear gradient, but a radial one. So the noise I'm going to put in the middle, so I'll do a swap there, so black to white. Okay. Now we've got our volcano kind of thing. Let's see what else we can do. I'll just put the noise here, and I'll leave it as it is. So now let's put another noise in there, in the grey bit there, copy to there, to the perimeter. So at the perimeter, I'm going to make it regular, which will make it softer, and whites that are less serious, so less deformation. If I lift up, then I can see that there's more hardness in the center and softer rounding outside. So it's a bit small, this object, so let's subdivide it. Turbo smooth. Okay. On the other hand, this plane, I'd like it to be very large, so I shall multiply its scale by 10, and the density I'll multiply by 10 as well at render time. So I've now got 80,000 polygons at render time, so my object is now 10 times bigger with that little thing in the middle. This little thing in the middle is my displacement map. So the displacement, I will make it bigger. Let's change its scale. There we go. Oh, its scale, all I have to do here is look, strength 461, and like that I can see the noise management. This is just a bit more on a larger area. If I do a little bit stronger, we can see that noise is reacting everywhere. Okay, this displacement is working well depending on noise, which is distributed in a radial gradient. Let's change the strength of the center of the gradient, so we'll add in a little bit more. We'll reduce the white, and let's change the size, make it a bit smaller, add a little bit of white so that it raises our general displacements up. Yep. Okay, if I go back to the other noise, which is there around the edges, for this one I'm just going to give it a slightly larger size to obtain more variation. There we go. And I'll reduce the whites greatly. There we go. So now we have a much smoother slope up to the center of our mountain. So we've now made some planes here. Obviously it's not going to be shown in the viewport here. That's part of what goes on with plane. We saw that before. Right, what texture are we going to put on there? Well, of course, here's the interest now. So we'll put this texture on my plane, and that will be on all the plane, including its virtual extension. I'll put a standard, very familiar image on there, except just to go a bit further. When we've made our image here, it's very simple. However, when you've made your image in whatever program you've made it in, just watch out for what's on the edges, okay, so that they go to the other side, okay? So because this image is going to be repeated across all the surface, and so you really want it to have a continuity across your tiling so that it doesn't show up too much, so that it shows up, so that your tile works better in UV or XY, no matter which one you use. If I do a render now, that's what I get. The image is on the whole of the geometry, including the extended bit. If it's a little teapot or it's a big mountain, doesn't matter. Okay, so here we can see my W is here deformed by the mountain, and the V and the U, and with the arrows that are drawn on the bitmap. Okay, I'm going to modify it now. I'm going to make it planar according to the object, local to the object. If I use real world for the repetition, it's not going to change a lot because it's planar to the object. It's true that I could subdivide it further, but these peaks could actually stretch out my image, which I don't really want, so there you go. Right. So I don't really want that, so what I'd like is if it was put all around it based on the world. Ooh, look, that reminds me of something. So for now, I'll change it to planar from world to XYZ. Now if I do a render, this is what I get. Ooh, it's tiny, tiny repetition. So let's up the size here. So let's change it to 10. Thankfully I put real world scale because it might be enormous on my teapot, but here on a mountain it's kind of tiny. And as you can see, this plane is huge, which now allows me to zoom in on my plane to approach it better and go in a bit further and see my image with lots of detail. There we go, one of the applications. Environment. Generally, rendering, you can find it in the rendering menu down here, environment, or 8 on the keyboard. It's pretty simple. First thing here is the background. You can either have a color or you can actually have an environment map. When you click there, you can click on all the different types of mapping you can do. Here, we're just going to use a bitmap. We'll use one like the bricks that we did before. Open. When you do a render, now you'll see that at the back of your image. Let me go back into materials. We can drag and drop as an instance, so we can work on it. We can see automatically it's in environment mode. It's not a texture that's applied to an object, but an environment map. Other techniques to load it into material editor is get material there, and you can do scene, and you've got the map there. A map number 1, brick 02 JPEG environment. And we can see there that we can rename the name of the file and what type of application it is. So when I double click on there, then it will just load it. There are different techniques here, obviously. When you load a texture, be careful though that you've got the little triangles that are in the corners of this image here. We've got them here, which means which are in all 4 corners of the slot, and here they're inexistent. That one is in the scene, and the material you're working with is instant, and that one you can modify, but it will have no effect on the scene. Basically, you just can't have lots of materials that which can all be instanced. Only one could be instanced. So up to you to choose how you import them, because you can display several, but you can't modify them all. You can only modify one. Of course, you can always reload it as an instance, and now it's got the triangles. Okay, generally, this is a traditional thing, and we've done this before. There we've got environment screen as a mapping mode. When you're making a texture, always think about your production workflow. This is very important, okay? You should always think about what final format am I going to use, and I'm insisting on final. Okay, let's take the example of a standard old TV, not an HD, but this is a size that's known by everybody, 720 by 576. Okay, and that's for PAL, obviously. That's pixels, and that's the final format that we want. Now, in theory, the background is not going to change. So what's in the background of your character, who is probably going to be animated, who's going to be moving, what's behind him won't change in size. Very good. Unless, of course, that your camera is not moving, but that's another thing. If it's not changing size, then the image that you loaded should be the same size as the final format. That's just normal, isn't it? It's the same size, and if it's the same size, it doesn't need to be filtered. Anti-aliasing. The anti-aliasing is something that adds an effect that will stop the pixelization of your image. By default, all images that are loaded are filtered. If you want to save some render time, especially for background images which are used in screen mapping mode, turn off filtering. At this point, you will get lots of render time back. If the image is not the right size, then you will have some pixelization probably, but of course your background image should be at the right size. So if I do some filtering here, and then I can see that I've got my non-filtered image here, and the one on the right is filtered. It's obvious when you zoom in. There you go. Crunchy, not crunchy. Not filtering, but smaller image, so you need a different one. But if the image is 1:1, no problem, and you'll get lots of time back. So there we go for basic background environment mapping. Next we'll look at other uses for environment mapping. Spherical environment. Okay, so we saw environment in background and screen mode, so relative to the final image at render time, but it can be different. So let's go back to rendering environment. So I'll choose our map here, bitmap. And we take this clouds bitmap. Okay, and now when I do a render, I can see it here. Of course, we can see it with Alt-B to see it in our viewport background. So use environment background, display background. Now you'll see it in our viewport. That's simple. You can, of course, see that if you use, say, a teapot and move it around, do a render, it's not changing anything. The background is not following the viewport changes because it's in screen mode. The principle is pretty easy to understand. The screen mapping mode means that your final render will always contain exactly the same image, and that's why you don't need to leave anti-aliasing on if you're images at 1:1 to the size of your render. Okay, so normally on screen mode, you've got your camera like that, and you've got background. The background is always going to follow the camera. That's all. Okay, this background is always going to be perpendicular and parallel to the camera. That's what I'd like is something else, though. What I'd like is that it would be relative to the universe, to the world. The background wouldn't be flat. That doesn't really interest me, but that it would be an environment, a spherical environment around my world. So at this point, I could take my camera viewpoint wherever I wanted to. This is an eye here, and there you go. So then I'd always have the background in the background of my object in the middle. If I used a spherical system, then that would be exactly the same as if I had a sphere, an actual sphere, and I put it in my environment, and then I'd have the same problems as with texture coordinates. So there'd be the line of the join of the images, and still with the pinching at the top and bottom like a sweet wrapped in paper. That's what I'm going to look at now. Let's delete this sphere, and I'm just going to go into here, M on the keyboard, drag and drop my instance of my picture here. Okay, for the moment it's in mapping mode is screen, so we could choose spherical, cylindrical, or shrink wrap, which is a bit strange. We'll leave it on spherical. If I leave it on spherical, then automatically the background adapts in my viewport. So there's the blue sky, and there's a little bit of the top of the sky. Now we can see the pinching that's at the top of the sky. To stop this kind of thing, well, mainly what you need to do is to rework your image. So go back into your image editor and rework your image. So let's choose this bit here, and let's just put some flat areas of color at the top. So I won't have the clouds going all the way up to the top there, just to avoid having this pinching. And down here, and I'll just put kind of a white over everything. There you go, a sort of grey kind of colour. Then you're going a bit brighter down here. Okay, so now the image is, I can save it now. I'll just call it FX. Give it high quality. Okay. Now I've come back to Max, and I'll reload this image. So bitmap. I'm going to choose FX. FX. I do a render, and we can see there's still a little repetition there. What is that due to? It's because of there's a pixel that repeats. Basically, if you remember that the sphere is the environment, and it's put over the top of our object, around our scene, if you like. And what's happening is that the texture at the join point, the pinch point, is the repetition of the one above. So you've got this the image that's surrounding the sphere here, and there's another one that's just above. It's the tiling. Trouble is that the pixel that's here is being repeated right here at the pole of our circle, of our sphere. So to get around this, which is often due to this kind of thing, so let's take off the grid. So to get rid of this, tiling, we'll just change it. To remind you, let's just go back to screen mode so you can see easier. If I lift up the tiling, then it shrinks the image, and it doubles the tiling, so let's put it back at 1. If I reduce the tiling, I'm enlarging the image slightly. Because the image is bigger now, if I go back to spherical environment mode, I can no longer see the repetition. That's it, because the image is now bigger than my spherical environment, if you like, so there's no pixel that connects the two things together when it's tiled. Okay, so that allows us to have a spherical environment that's more or less right. Don't forget that you can put whatever you like. So you can put everything you want to in there, like a gradient, in a spherical sense. This could be particularly useful when on your object you want to use, say, ray tracing. In effect, if I just go there and put ray trace material, then I will add a bit of reflection there. Now, reflection is going to use the background, and in that case it will use, what is the background? My spherical image map. The idea of using an image in a spherical background map is great, but the image I use is a JPEG, not very high resolution. We get very close to our limits. This image needs to surround your entire scene. We come back to our principle about images in your final image format. If my background was for a fixed camera here with just a background in screen mapping mode, then a resolution of 720 by 576, that would suffice completely. The problem is that what we're talking about here is a sphere. It's got to englobe the whole scene. So this size is hugely multiplied, which gives us an image that is much bigger, and especially in quality terms. And we don't want the camera to still get too close or too far away from it for a good look. So we'll need an image that's much bigger than this, that can also be recompiled on a sphere. So luckily there are some image formats that are really made for this kind of thing. The best at the moment is OpenEXR, which I really advise. It's got an alpha and you can pass it to various compositing applications like Toxic, Photoshop, and so on and so forth. The advantage also of OpenEXR is that it's a format that is being developed with sub-pixel information, but that's for a different training course. And of course there's HDRI, High Dynamic Range Imaging. What is that? It's a development that came about because cameras don't really know how to well deal with dark or bright. So bits that are very well lit or very shadowy, very badly understood by cameras mostly. So what we'll do is we'll have a quick look at what HDRI is. If, as an example, in a background I want to choose a different background image, so I can take this HDRI image here, and before loading it I'm going into setup, so I can change the white point depending on what sort of image I want. If I lift this value up or drop it down, you can see that the light points of the image are going to be changed in this place. HDRI images have several components contained in subpixel information. These components are exposure and the brightness of the image. But there we go. We'll take this like this and we'll do OK. Okay, and now we can see that I've completely saturated the lighting. Okay, first stage. Here the image is much better in terms of quality, and believe me, there's nothing we can talk about here. We can also see much better in here, even in the viewport, the details. If I do the render, the quality is going to be superior on my teapot, and because the image that's reflected is much better. And this functions obviously for everywhere. Obviously, that doesn't stop us having to worry about the joints of the image, but the quality is much better. To see this type of image, go into render, view image, and you can have a bit of look. Okay, and here's our image, and it's an image that's pretty big, and it allows us to zoom in and zoom out and have a look at all the effects that we've got. This deformation is to aid with spherical mapping, and we can also even create one ourselves. Okay, let's go back to view image. I'll take this one again, I'll go into setup, and I'll lower the white point. This means that basically it will reduce the amount of colour which is saturated in here. Okay. Now I'll open it now, and now we can see it's completely different. This allows me to raise the dynamic of the brightness in the scene. one of the great advantages of HDRI. The only problem is with things like alpha channels or other, and the interpolation, not interpolation really, but the exploitation that you can do towards a post-production application like Toxic or Photoshop. Here's our little look at HDRIs. Well, because it's very important to know about, especially if we're talking about spherical environments, but if I was you, I'd just look more towards OpenEXR and training based on that. So, could I make my own spherical environment map with a 3D Studio Max scene? Well, that's what we're going to look at now. Of course. The answer is yes. Okay, now I'll make a sphere. I'll put my random colours. So each creation I'm going to have a different colour. Okay. Now I'm going to make another box. Lift it up a bit. And now I'm just going to put a standard Omni light right in the middle. Okay. Important now. I'm going to put my camera in the center. So, why putting a camera in the middle? Well, putting a camera in the center is logical, because if I put my camera right in the middle here, then what I'll do is I'll make a spherical environment, well, kind of spherical anyway. It will take a photo of a bit, and then a bit, and then a bit. Well, it's a simple idea. Basically, all your camera is going to do is this. It's going to take an image above, an image to the side here, one down below, and one to this side, and it will just do a cubic environment. These images, these cubic images, are going to be made into a dome, and they will be welded together. It will try to do a correct welding of them together, because obviously the images are flat, they've got angles, so it will try to weld the images together into a dome. This dome image, made of lots of different images, is going to try and squish it down now to become a 2D image. Okay, in other words, what we'll do is we'll take lots of images here, we're going to put them into a dome. The dome is going to be squashed flat so that you eventually end up with a 2D environment image. It's the opposite process from what I did before. Generally, people who want to have a spherical environment map in the real world, they take a sphere, they take pictures of it. The sphere is nothing more than a chrome ball, and lightweight, you get a light probe, what's called a light probe. We're not going to look too far away from this. We're going to look at what we can do. So I've put my view here in perspective view. I'm going to convert it to a camera using Control C. So now I'm in camera view, and now I've put my camera in the middle of the scene. I'm going to go to Panorama Exporter, Render. I'm going to change the size, an enormous one there. Why not? So 3K by 1.5. And I'm not really bothered about that, so let's just hit Render. Automatically it's taking all the pictures, and it proves us with this. You can zoom out with the middle mouse button and zoom all around your environment, and as you can see, it's good. So File, Export, and you can save out as QuickTime VR if you want, in Sphere or in Cylinder. I'll do Sphere, and now you can choose the different types of image you want to use. Open EXR, there we go. JPEG, Radiance image, which is the HDR file format. So we'll just stay simple, we'll just make a JPEG. This is just a basic format training, so we'll go a bit further, but don't worry. We'll just call this one ENV for environment. We'll just hit OK. And what has it made me as an image? Oh, the easiest thing to do is go and have a look at it. View image file, ENV, and there you go, there's my image, like I explained. So it's flattened it out. This is a spherical image, which has been flattened into a 2D shape. Okay, so what can I do with this? Now we can do lots of things. So I'll go back to perspective view. I'll just delete this camera, don't need it. So delete. I'll come in here, I'll make an object. Guess what it is? Yes, a teapot. There we go. Let's take off that light as well. We don't need that, so we can see better. And now on this object, I'm just going to put material. And the texture is going to react to the environment automatically, like reflection. So if I use a bitmap there, if I use the image that I've just made, automatically on the object it starts an environment map texture. That's pretty cool, because that means that basically the image is put on the object as an environment. It doesn't care about the texture, explicit map channel and all that lot, just environment. When you put certain types of texture on your object, they just go on in environment mode, especially when they deal with light mapping. That's pretty interesting. That means that all these textures of reflection, they are additive. All the black that was here is not bringing any colour to our teapot at all. It doesn't bring any colour, so we've got our basic grey material colour. So now we can add the colour bouncing off our environment into our teapot. So we can see we've got a kind of HDRI effect. The other interest here is that it's an image. In other words, I could add some blur to it. And let me tell you that if you render blurred reflections, it takes ages. So there you go, an application for making our own environment maps. If we go into a little exercise which doesn't use a 3D Studio Max scene, of course you can do that, which helps a lot, but which is going to use an image and other things. So, well, let's go on to the next exercise. So here's a little exercise that's going to go over everything. Okay, so here we've got a bunch of spheres in a kind of cube shape. And if we go to rendering, environment, and here I'm going to load an image. So this, I'm just going to use this FX one, the one that we did to make our spherical mech, which would suffice for what we want to do. So we go OK. And this image, I'm just going to go into material editor, and I'm going to go an instant, and I'm going to do an environment map spherical. Right. Now I'll select all the spheres, Control A, and I'll go into material editor, and I'll just put a single material on them all, and it's just going to be not a standard material, it's going to be a ray trace material, and I'll put a little bit of reflection in there, quite a lot of reflection in there. And if I do a render now, let's see our render, we can see all our balls that are calculating the reflection of the clouds that are behind. Okay, I'll put myself inside the sphere, inside the cube, sorry. Okay, Control C to create a camera, switch to camera mode, rendering, panorama exporter, render. I'll just do a smaller one, and I'll just hit render. Now, as you can see, each render is being calculated, and just to remind you, the camera is going to create different images for all these different viewpoints, and I will have a spherical environment, or at least I'll export it that way. We can see the render here, the bottom, top, and so on. RGB alpha in 16-bit per channel. So here it's pretty interesting because depending on the quality you can zoom in or zoom out, and you can determine what quality you want. So there's my environment map that's made. So we can see that I haven't done the borders on either side of the image, so that there's still a line there, and the one on top is pretty much gone, but okay, never mind. We'll go to export, and we'll export it as a spherical map, and I'll just call it XO for this exercise. I'll just do a JPEG, that'll do. Okay. Let me close that down, reset, and now I'll load an object that I prepared earlier. I'll use fetch. There you go, that's my head. Right, rendering, environment. Now I'm going to use an image that uses the image and 3D. So I'll use that image that I rendered, EXO. And this image, always the same. I just put it on a texture here, a material here, and put it in as an instance so I can control it. Then I'll put it into a spherical environment map. And on my character, I'm going to put another texture, ray trace, on the person. So standard, change it to ray trace. And I'll put Fresnel. Should we see what that gives? Not that much there. So instead, let's just put some percentage there. That's a bit better. Okay, that's quite high. Right. Obviously, this is very tasteful. And what's interesting here is that now I've got my character head. I do a render, and I can have a look around. There's my first render. Remember the render time I had for all the spheres, and if you add in the head in there as well, and so we're considering all the environment here, it's looking at all the balls. The other advantage is here, obviously. The fact is that this background image is just an image, so I can blur it. And like this, I'm also blurring my background and the environment that's reflected in my head. Because it's a bitmap, I can go in here and I can add a color mod in there, like RGB tint, for example. So I'll keep it as a submap, and I'll go in here and change some of the colors. Let me modify the RGB values. There we go. There you are. So that's a far easier way of doing things using an environment and an environment map. This is really fast because obviously I'm just using an image. Here's an exercise that just recaps all the principles of texturing and environment texturing and a process of reflection on the object. You could even go a bit further in the sense that now let me take the texture of the object there. Now just put another material on there. It's a standard material. And on my object I'm going to put a map, and I'll go into reflection. And here I'm just going to use the image I used before, but without changing the colours. So now I've got a blurred image of a certain colour on the person, on the head, and delete the blur on the background image, on my environment image. And come back here to, let's drop down my reflection a little bit. Oh, not that much. And get a completely different effect. My texture in the background is a spherical environment, and the reflection texture is also in a spherical environment. So both of them are like that, and then we can mix and match. Let's turn off this reflection. Just deactivate it. I'm going to show you that I can do a copy here. And then up here on specular levels, and raise those, and we can see the highlight now. And in here, if I go down to all, I'll choose ray trace and reflection, and now it's calculating only in the specular highlights my environment map, use the environment settings just in the highlights. But I can use an image here if I want to. So paste my image. And what image am I using? Just my environment map, which has got exactly the same effect as if I'd used my environment automatically. We can't see any difference. Except that this one, I could make it blurry and it renders faster. So this kind of thing that becomes interesting now is the fact that images can be used for environments or can be placed on your objects depending on the UVW mapping. We'll do another application now using this little scene. Okay, we'll forget about the little kitsch aspects of this little thing, but as promised. Okay, now we're going to have a look with the same environment texture, what else I can do. So we're just going to reset everything to 0. Let's do a reset there. And we'll still use the same head, so we'll just fetch it back again. Okay. There we are. Now I'm going to use a first texture on it. Let's just go somewhere clear, so we can see what we want to do here. Let's put a diffuse texture on there. I'm going to use a checker. Okay, I want to see it in the viewport. Oh, wow. We need to really UV map this head properly. So we'll go rapidly. We'll go there. UV coordinates, UVW map, cylindrical. There we go. That's much better. We'll do fit. And convert my object to polys so that we keep the textures, and let's up the tiling. I'll make it 10 by 10. Okay, now the checkerboard is well positioned on the head. There's a little bit of stretching in places, but you know what to do with UV unwrapping. So this checkerboard is 100% on diffuse. Let's just reduce it a little. And at render time, that's what it's going to give me. What's interesting here is that I'm going to ask for the checker not to be shown in the window here. Right, just to remind you, the checker is a texture and explicit map channel 1, the cylindrical UV map. What I'm going to do now is I'm going to put self-illumination on there. And this is to add additive color to my object. So I'm going to go and find my image, bitmap. And EXO, that's the one that I did with all the spheres. And if I do a render now, that's what I get. The spheres, if I look at them, let's have a look at the texture. The spheres are placed on map channel number 1, but I don't want them to be. I'd rather that they were placed into an environment map, a spherical one. At this point, they'll now be in an environment map, and they are self-illuminating, and we can really see what it gives. And if I just go down and reduce the impact a bit, so turn that down, self-illumination, there we go. That's a bit more subtle. And now, if I add, obviously, it's a bit difficult to show both things at the same time. So let's put that one back. And if I put the background, it's going to correspond to the background that we had before. But if instead, rather than putting it in a spherical environment map, I'm going to put it back as a texture, and I'll put it back strong so we can see it better. But what interests me now is that I'm going to make it in explicit map channel 2. And I'm going to go back in here and go another UV map. Spherical 2, map channel 2. And now I want to see that texture in map channel 2. Now this channel depends on the gizmo, so I can move them around. So I can center it for the object. Let me change its scale. And why not rotate it a bit? Since it's auto-luminous, I obtain exactly the same principle as if I had a projected texture in spherical with the environment map, except here it's attached to the object. and I can amuse myself by doing lots of different things. There you go. There's different things that you can do, different reminders, and there you go for you to play now with all these techniques. Now this also allows us to turn little effects like chrome or glowing or lights diffused on an object like reflections or like compact discs that turn and things like that. So it's really possible like this to distribute your textures as a spherical environment map with you that generates how you want them to do, or a spherical environment, or use screen and do special effects. There you go, why not? Okay, so this speciality of the screen environment map we'll have a look later on for doing a kind of Magritte kind of thing. Okay, so now we're just going to first we just environment, and then we haven't finished yet. Let's just put the clouds there, open. If I do a render now, by definition, it's just going to be in screen mode and I can just see the whole thing. Now I'll go here and I'll import my head. And I forgot because I imported, I've lost my map, my background. So that's not a problem. We'll just go back here and bitmap and choose it again. Okay. And there it is in screen. And now if on the object you put a texture like this one, and you put diffuse, bitmap, and you take the same picture, it's going to follow the geometry of your head. It's going to use a UV map, and if you use the environment screen, then it's exactly the same as the background. So like this, you can have something a bit sort of Magritte, where the person is following the background. There you go. Camera mapping. Camera mapping is something often used for special effects. Camera mapping works exactly like a projector, except that the image projector isn't additive. Okay, we'll have a look again. We'll make our little object here, and we'll make a sort of wall, and we'll make a camera here. So there it is. We'll move it around a bit. So we've moved the camera and the target point. So I'll take my object, I'm going to put a texture on it. This texture, I'm going to put a checker on it. Checker, texture, explicit map channel number 1. If I want to see it, that looks there. It's automatically put on the object, which is a primitive. On the other hand, if I go into modifiers, UV coordinates, camera map, I've got two ones here. I've got camera map and camera map WSM. I'll take the first one. Pick camera. Now, automatically, do you see? The texture is placed as though it's projected by the camera. That's simple. It's not very difficult to understand. So, the projection of the camera is here. And the texture is scaled to be within it. That's what we call camera mapping. This projection is always perpendicular to the camera and also parallel to it. Okay, so if I've got camera map here, why do I have a second one? WSM one, World Space Modifier, that stands for, and an ordinary camera map, and that's the one I used. So what does that mean? It means that if I move the object, the texture is stuck to it. If you want to reinitialize it in accordance with the camera, you need to reselect pick camera. There you go, it moves. The map channel is number 1, and now you can add textures with the other map channels, but I won't go back there. But obviously that goes through all the modifications of my camera. Now I do pick camera again, and that will follow. What's the difference with the other type of camera map? So let's delete this one, and I'll take the other one. Modifiers, UV coordinates, camera map WSM. Okay, pick camera, and I'll choose my camera again, and it doesn't look like there's a big difference, except here it's interactive, so that will follow non-stop the objects, the top level of each one. So if you move one or the other, they're always connected. They're always instanced. So world space modifiers, each one keeps its own object space. So there you go, I move the box and the camera is always interactive with it. We're going to go and have a look at an exercise to show you how this is used. Here's a simple application for our tools, or at least maybe useful. Okay, two planes, and let's give them both the same texture, and texture is just going to load an image in diffuse, so I'm going to take a bitmap and I'll choose the wood image that we already know. I'll ask to see it in the viewport, no problem there. Alright, if I go into front view, and now I'll make two cameras. One there, and the second one here. Let me go back into perspective view, and let me have a look. There's my camera, and there's the other one. Okay, for the first box, I'm going to modifiers, UV coordinates, camera map. Pick camera and choose that one. There you go, no problem there at all. Now I'll take the second box, I'll take modifiers, UV coordinates, camera map WSM, pick camera, and I'll click. There doesn't seem to be any visible difference, except if I move the plank, that's what I get, and if I move the camera, that's what I get. Oh, it doesn't really interest me at the moment, so I'll delete those. So just keep this one. Okay, the texture is applied by the camera. So what I'll do now is make a sphere, just a really simple sphere, base to pivot. There we go, this sphere, I'm just going to change its scale down to flatten it. And now I'm going to put another texture on it. I'll duplicate the texture there, and I'll change its name. I'll just call it test. Then I'm going to drag and drop onto the sphere. Okay. By definition, the sphere, which is now completely flat, I'm going to put a camera map WSM. Okay, and choose the camera, pick that one, and now that I know that it's interactive. Aha, very simple. So this is not bad at all, because now if I make a liquid, change its transparency a bit. Okay. Maybe not in the viewport. I've got some display bugs there, so I'll just change it there. Okay, right. Now I'm not going to move the plank. I'm going to move the sphere. I'm just going to leave it as 100% opaque, and then we can see. All right. So at render, I'll change the transparency. Don't worry. So here we can see that there's an effect that looks like a deformation. And if you change the camera in position just in Z, you're changing the amount of refraction. You see? Isn't that cool? In real time. Like that, you can make fluids that slide on another object. There you go. That's the principle of camera mapping. The camera could also calculate all the background details, so we could avoid this kind of surrealistic effect where we move the blob of water off the plank where there's nothing. So let's stay here, and let's lift up the specular level and reduce the glossiness. Image, I'll just make it a little bit of blue. So the image is covering the object at 100% at the moment, so let's just drop that down. And so we've got a render that's a little bit bluey. And now let's just reduce my opacity and keep hitting render so that we can see the two effects. So the image that's behind and also the deformation that's over the top. So now all we're going to do is animate very simply. Of course, we could do some structural deformations on there, and it will all follow without any problem. We're just going to make an animation quickly. So go to render, setup rather, and we'll choose range, and we'll go from 0 to 50. There's no point doing all 100 frames. output, we'll just make an AVI in my cgitrainer.com folder. We'll call it test 2 and choose AVI. Render. And now obviously, because of this principle with this texture, there's no ray tracing, there's nothing. The effect is quite nice. It might suffice for little basic things. It's just an application that is worth what it's worth, but it's worth an effort like that. We're going to have a look at the video now. And there we go. We can see that we can see the deformation over the top, the refraction if you like, and the transparency where we can see the plank for camera mapping. So there you go. The first one is for a fixed texture, the second is for deformation. We're going to have a look now at a tool that will help you to perfect a UV texture that you've got applied on a model that's already, you've worked on it a lot, with a couple of errors now. So it's called UVW Xform. So what it will allow you to do is perfect areas where there might be a problem. So like this one on top of his head. So what we'll do is have a look at it. So modifiers, UVW Xform. Okay, so what this does is it allows you to move the texture around. So I don't really want to do that. If I lift it up, no, I don't really want to do that either. That's good for the hair, but not really the rest of the face. So like this, we've got rotations, and we've got rotate about center as well. Okay, well, all these things, all we need to do is change this hair. So what we can do here is go back to editable poly, take the faces that correspond to the hair. There you go. Just going back to Xform, and now you're applying on all the object, or you can just go on the whole on the section. Here, what I'll do is I'll just lift up my V tile and take away the hole. That's all. So, if there are errors on your UV map, this is great. But now we're going to have a look and use Turbo Smooth to smooth out our mesh. Oh, I've just taken just his hair. The advantage here is that we can go back into a topology because we're going through the modifier stack, so we can just take away the faces we don't want with Alt and come back to Xform, check that it's working. Turbo Smooth is still working because those are the faces that needed to be smoothed. So here's one of the applications of UVW Xform. It's not more simple than that. It's just for finishing off your textures. It's not for making them, but for actually correcting little bits to perfect your texture. There you go. I hope you'll find it useful. So here's a utility that can be really useful for objects like walls, anything that's vertically oriented. We'll have a look. So it's called Map Scaler. So we'll make a box so we can understand. On this box, we'll call it a wall. We'll give it a length of 50, width of 50, and a height of 1 meter. Okay, I'll put a checker texture on it so we can see the deformations. So checker. There we go. Texture coordinates, basic ones, so we go UV map and change the tiling so that we can get squares like this that are a little bit more interesting at different places. So now we can see the repetition. That's good. Now imagine that we need to make a copy of this wall, and it's got to be bigger. So we'll make up our copy, and I'll want to modify its scale. So go here. I'll just make it 2 times the size, so 200%. So the wall is bigger, obviously, but the bricks have also scaled up, and that's the problem. It's obvious. The bricks that have made the two walls need to get bigger because the walls got bigger. So UVW map scaler. At this point, now you can just scale the mapping to get the same size as the previous box. The same shaped bricks for a bigger wall. Different channels, very traditional. That's the principle of map scaler. In this chapter we're going to look at something a little bit special. It's looking at the additional info in your mapping. It's not mapping here, this is information about mapping. It's not really for us, it's more for games creators, but I'll show you anyway so that you can see it for yourself. There's going to be any exercise or anything. Sorry, well, this is not a game. Here's the teapot object that I just made, and I'll look at its channel information. I'll go into utilities, more, and I'll go to channel info right here. It's already active, it's there. So hit OK. And go channel info, and what do I find? I find the number of vertices, number of faces, and the size in kilobytes for each bit of information in our object. We can add more information into this list here so that games creators can see the cost in kilobytes of each layer of information in our object. So there's 6 bits here. If I add in a UV map, for instance, update, and now I can see there's another layer in there, so now 7. And over on the right hand side I can see that 12k added. I can see all the information that's added to my object. So for us it's not really got a very great interest because we're just doing audio visual stuff and we're doing render, but for anybody who needs to know the exact size of their objects, for them it's interesting, but like I keep saying, it's not a game. Mapping clear. It's the deleting of UV maps. We've seen different utilities. So in the case of my character with his complete mapping, UV mapping, different things. So map channel 1, map channel 2, 3, and so on and so forth. So if I go up to the modifiers and choose UV coordinates, UVW mapping clear, it will delete the channel I want to. So map channel 1, map channel 2, channel 3, and so on and so forth. So what this does is delete the UV coordinates for using the map channel. So there's nothing simpler than this if there's an error or to do certain effects if you want. So there you go, that's what UVW mapping clear is for. We're going to see another type of camera map here. In 3D Shading Max, there's one called camera map per pixel. So the principle is pretty interesting. It's often used in cinema special effects. So here we go, a little bit of theory. So let's imagine that we're in the real world. Okay, so I've got my character here, my little person. There we go. Who's not moving very much. And he's obviously in the real world. To have the textures on this person, so we do a photo in front, we do a photo from the side, and so on, to have this kind of cubic environment map. So we've already understood that we needed to do different types of photo to allow us to have an image that is constituted of several different angles, which are then stuck together, and to do retouching to make sure that we get them both stitched together properly, without forgetting of course the stretching of the image that's going to be because of the UVW distribution when I put my 3D object around these textures. So there we go, we've already done all that. Now let's imagine another technique. Here's my person in the real world. He's very happy. Okay. And I'm going to take a photo kind of here from the side, photo from the other side, one from this side and one from there, one from underneath, and I'm going to photograph everywhere pretty much similarly, but all the person, obviously with the face. So what I've got now is an environment of the 4 faces and the top and bottom. So I've got 6 photos. Wouldn't it be interesting, wouldn't it be useful in 3D world to be able to do that kind of projection with a camera a camera map, very simply, on each view. This time we need a camera here and a camera here, there's one there, and that's another camera, and this is a camera. Okay, and this camera projected, I might have a problem, so I might have an image that's coming down here that is cut. So how do I get the projection from here and a projection from there and the mixing of the two? Without Photoshop, it's not going to be very obvious. So in 3D Studio Max, what's the solution? Well, here's how we do it. This is what is our thing now, which is how to mix different cameras on a single model in 3D. We're going to do it using a simple sphere so we can understand. Let's make a sphere. I think you know how to do that by now. We're going to make a camera. Target. And we're going left view, so we'll choose the 2D view. And there we go. On this sphere, I'm going to put a material. And in the diffuse channel, we're going to use checker. Ask to see it, and there we go. If you do a checker, then our first reflex is to use UV coordinates camera map. No. Here, this is why it's a bit different, is in the material. So rather than going into checker, so let's delete that. We'll go in here and we'll go camera map per pixel. So in the diffuse channel, that's what I'm going to use, camera map per pixel. So now I choose the camera I want. There we go. Take the texture and I'll choose checker. Let's go back up. Z buffer mask, that's the idea. We're going to see this later on, and we're going to see it in the rendering section. Don't worry about it now. Mask, and the mask will follow the camera projection, or is going to be placed according to the UV coordinates. The mask, don't forget that you need to use black and white. Where it's black, it's transparent. Where it's white, it's opaque. So here there's a tolerance. It's impossible to see it in the viewport. It's a render thing, so there we go. The texture is projected by the camera. The camera is about here, and it's projecting the texture here, and it's stopping there on its cone. Okay, except here I can actually up the angle threshold. So I can reduce it, or I could increase it. Now that's just one camera. So how do we add a second camera? To do this, we'll go to another type of material. This process of camera per pixel does need to be contained in a material that's capable of mixing. So to continue our exercise, now we'll look at composite. The composite material has already been seen other places in this training. But now, let's just have a little reminder, especially since it's going to go quite quickly. So let me just create a box. I'm going to put a texture on it, a material, and in the diffuse channel I'll use composite. Composite, I'm going to use a bitmap, and I'll take this one that we know well, and there it is. Now go back up, there's the composite. Now let me just make a new layer to there. This is to do all the layers that are there, so let's add a new layer there. And here we're going to make another bitmap, and we're going to use wood this time. So if I ask to see it, now all I can see is just the wood. If I ask to see them both, that's what I can see. See, I can change the opacity of the wood, and then I can see the mix of the wood and the UVW map. And that's the principle of compositing. So it's a mix, and it's the modes here comparable with Photoshop or other image editing packages. These are blending modes that we see everywhere. We can, rather than just working on opacity, we can use a mask. So I'll take checker, and now it's based on the black and white of the checker, which we can see straight away here. And obviously we can blur it, but we don't see them in the viewport, only at render. Just a little tip in case you're wondering why you can't see it. Okay, so this is a pretty quick little demo, but you can see how it works. You already know. The composite like this will allow you to add things to a mix, which is exactly what we need for the camera map per pixel. So let's reset, and let's go back to our sphere, in which I'm going to use a camera map. So target, there we go, in the front view, and let's create another one here on the top view. So now I've got two cameras and my sphere. Okay, to get rid of the grid, take my sphere, I leave the cameras accessible for selection so I can see them. Let's go into the material editor with M and put the material on the sphere. And now in diffuse, I'm going to put composite. There we go. So here, I'm just going to put camera map per pixel, and I'm not going to select anything. I'm just going to back up. And now on duplicate layer. Duplicating the layer like this, I'm going to have, each one is going to have a camera map per pixel. Put in as many cameras as you've got in your scene. And now let's edit it. So choose the camera here, and choose the texture, and I'll use bitmap, and I'm going to take this fence texture. I'm going to ask to see it, but it's not going to show you anything very reasonable. So here we can't click to ask because camera map is only at render time. So if I do a render, I can see now that it's based on the camera that's up here. Let's go back up. Let's take the second camera map, change the second camera, and now another texture. Let's bitmap, and I'll take the UVW one. Let's do a render, and now I can see the second texture is here, which is covered by the other one. Like this, you can actually put several on there. The protection, the distance that it can actually cover the object is managed here with angle threshold. So let's up that a little bit, and I can see now that my projection of my texture is growing. To use a mask, let's go into the other camera, and I'm going to use a mask. So several possibilities here. So either I can use a fusion mask here, or I change the opacity here, and I can see that now the two textures are visible. Or I can use the mask that's here. This mask, the advantage of it, is that it can use camera projection. So if I use checker, for instance, and don't forget to activate it, obviously, I can see that it's the checker that's using the projection of the camera. So, or you can use UV coordinates. So let's turn that off and go back up, and now I'll use a mask here, checker. And this one is going to correspond exactly to the explicit map channel. So it's you that can change the tiling and so on, and you can place it according to another UV mapping coordinates. Like this, it's completely possible to put masks. To delete it, we click and we hit none. So we can put masks here that are based on UV coordinates, or go in here and put in the mask in here based on camera protection. We can also use gradients or blurs or whatever to work to fuse those two bits together a bit better. You can even include textures that are on the object of the camera map. So for this, well, let's go and have a look at it now. Okay, so let's go back up, take the mask that's here, and I'll put a gradient in there. The gradient, I'm going to make it radial, and I'm going to show just him. So there we go. What's white is visible and what's black is not. Let's do white, white and black so that the visible zone is much bigger. If I do a render, that's what I get. Here I'm going to change the map channel to number 2 just for the gradient here. So, and the map channel here is going to be in channel 2. I select my sphere, modify, UV coordinates, camera map, WSM. And so camera map, I'll choose channel number 2, choose the camera, I'll choose that one. And let's turn around a bit. And it's my camera that's making the gradient. if I get closer, then I've got more or less of the gradient that's visible. If I look carefully at where the camera is looking, it's this which is going to determine the center of the gradient. Okay, so there we go, one of the tools, one of the uses for different applications, and here we're getting more towards the advanced level of effects or whatever, and here the training that we're doing is pretty much beginner, medium, and it's just getting used to stuff. The camera map we've used here is the one you'll find in the materials, and I did a mix, remember, with camera maps that we got to modifiers, UV coordinates, camera map. Okay, to start with normal maps, we've got to start with theory. What, do you think something else would happen? Okay, a sphere. And it's made of faces. If I ask to edit normals, I can see that I've got the orientation of my normals. The normals are these little lines that show you where the exterior of your polygons are and show how the light can pass from face to face. Let's turn off the grid. Let's go back to my sphere. Let's show everything. And I'll reduce the number of segments. I'll go back to normals, and I can see there are a lot fewer normals now. The orientation of the normals is just this. Okay, I've already looked several times at this in different parts of our training, so I won't go back to it very much. The normal, I can change it around, and it allows me to alter the bouncing back of light, which means that you can end up with black spots or white spots, as though you had a mirror or a mirror ball that you're sending back light. So the orientation of normals determines how the light is sent back. This sphere, I'm going to add quite a few segments, 20, maybe 50, why not? If I now have a look at the subdivision by hitting F4, we can see it's quite well subdivided. If I now go down to edit normals again, that's quite a few normals. This sphere I'm going to convert to poly, and I will subdivide it in NURMs, which is polygonal properties, and you can go back to see modeling chapters if you want to see that. If I use the new graphite modeling tools, I'll convert to poly, simply here. It's easy enough, and at the same time I will let's just show everything, it'll be easier, and at the same time I will go on subdivision. So here some menus are missing because I'm not on a large screen. I'm just on 1024 by 768 for this training, so I've still got this one on the side. So I'm going to go down here and go down here, use NURM subdivision. We can deactivate the menu that's on the side, so we want more space. So there's the NURMs there. For when you are in too smaller a workspace, you can just hide that menu that's there with this button here and re-show it again, and we can find use NURMs there. So use NURMs is active. So let's go into freeform and use the tool push pull. The brush will allow me to do what? If I use the brush on my object, that will allow me to modify the orientation of the normals. So if I go back into subobject points and then take the brush, I want to change the size of my brush. Remember, it's not very complicated, it's Control Shift. And we can see the size is changing. To change the strength of the brush, it's Alt plus Shift. If I want to paint now, I just press the button, and I'm going to lift the points up. You saw I moved into point mode. So if I hold down Alt and I paint, then I'm pulling in. Okay, I'm going to quit the subobject mode and quit subdivision. So now I've changed the orientation of the normals. To see how this works, I'm going to do something very fast that will show us the orientation of the normals and translate it into the form of pixels and colors, so you can see your normals like that. So we'll go to Unwrap UVW. Here I'm obviously going to choose, let's just hide this. Here I'm going to take all the faces, Control A, and now I'm going to do a spherical texture. That's pretty obvious for this type of object. No, I'm going to go into Edit, and there's my spherical texture. If we go into the mapping tools here, okay, render UVW template, and we've already seen it, so I won't bother showing the overlap. I won't show seam edges, and I won't show visible edges. So when I do a render, I get nothing. No great surprise, except that if I go to solid mode and do a render, then that's my solid mode. So that's my object here. I can go in shaded mode, and that's my object, and now I can see how the light is bouncing off my object, and I can see the two dents that I put in my object. So we've localized it a little bit. So now if we go into normal rendering, what do I get? I get a variation in colors, above all where my two dents are. We can see that the bottom of the sphere is a particular color, so we can see top, bottom, and the top a different color. We can see the colors that are symbolized here at different places, so we can see the orientation colors like this. Based on the force, based on the strength, we're going to find the same strength, and if it had been the same color, it would be the same relief as the sphere, which would be a bit bizarre. So that's why these are just suggested, if you like. The normals are interpreted by the variation of this color. Okay, so here we go for our first look at normals theoretical. This will help us to understand the next chapter. Here's a use for normal map. Okay, so here's some mesh and some texture, some more mesh, some more texture, some more texture. Oh, wow. Yeah, okay, so this object was retouched in a paint-based modeler. So I think it was in Mudbox or whatever, I'm not sure. So let me turn off the mesh, and let's just see the high definition object with its texture. This object has got an awful lot of mesh displacements and a very rich mesh, as we saw. Reliefs and or bumps and displacements are based on images with normals. That colourful image which shows all the normals in different positions. Okay. Right, so what I'll do now is use a trick to use on this object, which is much lower in mesh. So it's the mesh is a lot more optimized. To do this, what we need to do, there's a very simple technique that we'll do in UV coordinates, and there's projection. Projection will be done automatically, so I won't do it here. I do it instead by going into render. I go render texture, and we've already seen that we can directly use the projections. So the condition is that this object is positioned in exactly the same place as our target object, so that the displacements are based on a common center. This approach to normal mapping is going to close our modeling apprenticeship here, and we're going to move straight on to rendering. Okay, we'll continue. We don't really need to see it, so we're going to object properties, and then all we're going to see is we just want it displayed as a box. So there we go. Now I'm going to directly align it onto my other object. There we go. So graphite modeling tools, I don't need them, so let's hide them. Now two objects are both in exactly the same place. If I select the low poly object, that's the one with far fewer polygons, much less geometry. And we'll go into rendering, render to texture, and here we go. So I'll choose where I want to put my image, the bath. So we'll choose www.cgitrainer.com, UVW, OK. And we can see that it's the JYA low monster that we're using. And we're going to do projection mapping, so we'll enable it here. Okay, now it's very simple. All it's going to do is use the modifier that we looked at before, projection. We now need to pick our high resolution object, and it will give you a list anyway, so we'll take the high resolution there. That's the one that we want to use the normal map from. So we'll add it, and if you look now, you can see the JYA low object now has projection in the modifier stack. Projection puts a cage around your object, your low level object, and it's larger generally than your original object, and you can adjust the points or whatever you like to adjust it to make little subtle changes if you want to. Okay, once done, this is pretty easy now. All we need to do is go down here to the render, and we add, and we want a normal map. So that will produce a normal map, which is an image that corresponds to the orientation of the normals. And we're just going to show output into normal bump. And the image is going to be a TGA. You can choose other types of extension if you like. When I do render here, it's going to say it doesn't support target map slot, and you just don't care to continue. And what's great here is that it will do the render of the image like this, but it won't actually display the normal. The image you've got here is just a render image. This is great because my low object is low poly object already had a UV map. Don't forget, you need to do a UV texture map to start off with. That's how you start unwrapping the object. So this is how we do it. View image file, and we come here, and we can see JYA low normal map. Open, and I can see my normal map. The orientation of the normals of my high polygon object. Now this image here is a bit small, so let's start again, and we'll make the image a little bit bigger. So let's do a 1024. Render, continue. I'll overwrite my file, and it's doing render the text a little bit longer, but that will also obviously be a little bit more detailed. The red bits there are faces that aren't taken into account or that might have problems. Since I know these polygons there inside the throat of the animal, I don't care. It doesn't create too many problems. So there's my rendered image at the end of the render, and my normal map, if I go view image file, it's this one here, and I can say OK. So that this image file is taken into account, don't forget to tick output into normal bump. Okay, so that's it for starters. Okay, and now what do? Well, now you've got this image, you delete the projection, which only was used to editing the normals using the high polys that was this represented by this box. I'll delete that box too. Now I'll go into my material. I'll apply that material to my object, and in the maps, go into bump. You can see normal bump. So hit OK. And now I'll just take my normal map that's here, so bitmap. There we go. And now you can add another one if you want to. The other one is a standard new bump map in grayscale. If I do a render now, here's my polygon's a little bit different to what's in the view. It doesn't look very different, obviously. Let's just up the bump a bit and do another render, and now you can see that it's really exaggerated, but don't put too many because otherwise you could end up with some strange things. So now we'll go a bit further with display acceleration. So here we are. Each time I do a render, I can see my normal bump that's on my object, but I don't see it in the viewport. Normal bumping works on game techniques really. So let's reduce my material editor a little bit here, and let's see what it's got down at the bottom of the list. DirectX Manager. If I go in here and use Metal Bump 9 and activate it, somewhere here. Oh, there we go. And now you can see my object looks a little bit different in Max. So let's go up now, and I can see several different options for real-time visualization. This real-time visualization permits game creators to work and to see aspects that they'll see with DirectX. Hey, look, bump normal. So let's tick there and find my bump file, and there it is. And if I lift it up, I can see that my bump is on my object. Okay, but blue, I don't really like it. So what do? We'll go up here, and we've got ambient and diffuse, and we've got texture, and we can just load the monster diffuse texture, and there you go. And now you've really got the aspect of a high poly object, but in a much lighter object, because if we look at the polygonization, it's much lower than the high poly model. And so that allows you to simulate relief or bump mapping thanks to normal mapping. But now we're getting closer and closer to rendering. And so let's move on to the next part of training relative to rendering. See you soon.